Good morning, everyone.
Rich, did you get a chance to download that recording from yesterday?
I did not. I should probably actually do that now.
Yeah,
Thank
because
you.
I'm out of space on that thing, so
Gotcha.
I exceeded my quota. It's a pretty big file.
Interesting. It's saying that I am out of storage as well. It won't let me access it
Hmm.
because I'm only on the basic plan, which is only 2 gigs.
Right, exactly. Yeah, that's what I'm using. Let me see how big that file was. I may have to empty it for other things.
So yeah, I've already downloaded all the other material. I believe that you said that you added one additional file though. That one I did not grab yet.
Okay. Let me see how big that was. Hmm. Where is it? Hmm.
Is there any way to compress that file?
Um,
I don't know if you can zip a
yeah,
recording like that.
I don't know. I tried it in the past and it didn't yield much, but I could try again. Now, of course, for some reason I can't find it on my. I didn't delete it. Shoot. All right, I'll have to look for it. See if I can. Probably have to delete it from. They let me even delete it. I don't know because I tried to access it this morning and I get the same message as you're getting. It's like you're out of space, upgrade, or or I
Right,
don't know
right.
what. Yeah, yeah, exactly. So, um, see if I can go back. Let's see. Okay. Maybe not showing me file info copy link. I just went back in and now it does let me access it. So let's see if you can just close that page on the browser. I went back in.
Okay. Let me give that a shot.
Try give it a shot. Um, Meanwhile, I'll try to find it, see if I can. Otherwise, I may have to delete it here and then see if I can compress it somehow.
Oh, yeah, that worked. Now let me in.
Okay. Yeah, it's
Okay.
almost
Let
2.4
me.
gigabyte. Yeah, if you could just download it and then I'll delete it.
Right.
Yeah, but that was just 4 hours. So,
Okay.
yeah,
Right.
it generates gigantic files. Yeah.
It's crazy how big those files get so quick.
Yeah. Yeah. Yeah.
All right. So I'll have that downloading in the background. My internet connection isn't the greatest here at home, but I guess after this training session, then we can go ahead and delete that one.
And delete. Yeah. Yep. All right. So let's see. I
but
think
it
we
says it's
have
downloading. So
okay, except Alejandro, I think, is not here yet. But
very
are there
small.
any questions from what we talked about yesterday? And then let's
Not for me.
okay. Well, do you want to continue, or do you want to wait for Alejandro?
Yeah, I think we should get started, and I'll just be downloading this in the background. And once it's finished, then I'll let you know, and we can delete that one.
Okay. All right. So we looked at some of the relationships, right, from a requirement. So when you relate the requirement to, for example, other requirements, typically you would use derive, right, because you're deriving from your top level requirements down. There's something called the copy dependency, which the tool does not support anyway, but it's also pretty, I think, pretty unlikely that you'd need it. But the idea is that you have, two requirements, maybe for two different, or same requirement for two different products, for example, right, for different projects or two different systems. And so then the one would be a copy of the other, but then the tool will have to make sure that that it gets cloned, right? Then it's a read-only copy. So I think the more, if you ever run into that, I think you might as well just take those requirements and move them into the library, right? And just reuse the requirement from the library. Of course, they wouldn't physically sit in the folder structure. So there's pros and cons to that, but um, that may be a better solution in Sparks anyway. The other one that you're going to use extensively, right, is satisfy, because if you have requirements at any level, right, at some point you have to show something in your design, in your architecture that satisfies the requirement, right? And so, you'd use that pretty much with anything that you have in your design. Could be an activity, could even be a single action in an activity, single step in the flow, could be a block, could be a property of a block. It doesn't really matter. And let me go back here. And so if you have, like this block, for example, right, you could say that if we switch to requirements, right, so we're looking at these requirements here, right, you would basically say that, and the tool probably lets us do this anyway, very with the quick linker as well. Yeah, see, there's a satisfy, right? I know here it says satisfies, here it says satisfy, right? Maybe to make it easier to read or something like that. But don't be confused. Like, when they say refined, it's the same as refine, and then you'd say satisfy, right? So here it's a block, an entire block, right? But like I said, it could be a property of a block, could be an activity, anything. But at some point, you're going to have to show, right, that these requirements got implemented, right, somehow. So that's the relationship that you should use. Again, not graphically, but I'll show you that tomorrow, how to set up a relationship matrix. And do it very quickly. But that's the purpose of that connector. And then where's my slide? The next one, typically, right, test cases, right? Um, how you verify your requirement. I don't know if you're going to do, at least maybe define what the test case is. The tool doesn't really let you run tests or anything like that, but you could define what the test cases are. So if I put a test case there, right, then I could say do the same thing, right? And the tool will say verifies here. So that's the intent there. And of course, you could use some other kind of element if you didn't want to use the test case thing here, but and still use that relationship. Then refine. So that's typically like between, excuse me, like use cases we'll talk about tomorrow. So a use case could be considered refinement. So anything that, or sometimes people do user stories, right? So like little scenarios, right? How, let's say the driver of the vehicle would use one of your components or something like that. But so anything that basically is considered that it gives a better documentation or puts more meat around a particular requirement. So you would use a refined relationship. And then if you have anything else, you say, well, I have some, I have some other traceability I want to build to requirements, but it really doesn't fit any of those categories. You just use trace. Right. So trace is like, the catch-all where you just have traces right here. Right? So these are kind of your option within the SysML space. So here's like, some generic abstract, case, test case, right? Verifies a requirement. A requirement can trace to another, or anything can trace to another requirement. It doesn't matter, right? Use cases, user stories would refine requirements, etc. Creating, I think we already talked about that yesterday. In terms of, well, so remember, you do have two special properties, which are not SysML specific, just the tool gives you, right, which are difficulty, priority, and then of course the status of a requirement is typically something you want to keep track of in the tool as well to know, okay, yeah, it's, we have a solution for it, right? And remember, you can customize these values here. So, something that says that, the requirement has been, implemented, or it has been, validated, or it's been tested, or it's been approved, or so these may be the alias field in the tool for a number, right? Requirements numbering, like we talked about yesterday. So these are kind of the main fields that you may want to use in the tool to help you define these requirements. This one we talked about yesterday. So here's an example, again, from that defense contractor that I mentioned yesterday, in terms of, so their customization, right? So this, the system requirement, of course, in their world, they have, a ton of stuff that they, need to keep track of, right? Like the target software, built for software. They had their own classification. So remember yesterday I talked about, the extensions, right? That, come on, keeps giving me a hard time, right? The extensions that are kind of built in but hard coded by Sparks. So I mean, they kind of use the same nomenclature, but they wanted to be able to extend it, right, and have additional properties on it. Where'd it go now? Oh, okay. So kind of see that performance interface. What else? Verification method, right? They added that. So these are all like custom properties, right? The rationale, set whether that requirement has a safety implication, is safety critical or not, whether there's a cyber risk, which is, in the military, obviously is a major issue, and other things like that, right? So I'm just showing you an example of, you can say, okay, here's, right, if you ever think about, right, wanting to add more to the requirements, or sometimes if the requirements are currently kept in some other tool, we can bring them in, let's say from Excel, to like an import from Excel, then we could have the import itself can actually create, right, all these extra custom properties that the other tool would have, just replicate them in EA. That's very simple. So alias field, we already covered that yesterday, right? For, again, for requirements or for anything, the tool doesn't care what you use it for. The compartment, nodes compartment, right? I showed you that. So you could have nodes visible if you wanted to. I think I did that yesterday with one of these
So
guys
real
here,
quick
right?
on the
Yeah,
the
go ahead.
importing fact. So we have all of our requirements in Polarian, and we've been told that there is a linkage to be able to pull requirements from Polarian into Enterprise Architect, but we have not seen it done. Do you have any experience with that?
Uh, I have no experience with it. Well, we'll take a very quick look here, on the Sparks. I'm looking on the side here. Excuse me. Let's see. Where would I do that here? Polarian, right? Let's see what it
Correct.
comes up with, because they have, like, I don't know, 20 different, or something like that, integrations with different softwares. And so I just want to do a quick search, see if I can, if it pops up on the list. Polarian integration. Here we go. Um, so let me just bring that over. All right, so Exchange Data Enterprise. Oh, okay, so using the Pro Cloud Server, right? So yeah, all of their integrations are going to be with the Pro Cloud Server. So that, from an IT perspective, is just a way. So when you have their standard license agreement, you already have. You don't need to buy anything more, right, to get the Pro Cloud Server. There is some options where you can buy. If you wanted to have, like, many databases, on their server side, on the cloud side, etc. And by the way, when they say cloud, I mean, it could be, I mean, literally could be Azure, or could be Amazon Cloud or something like that. But I mean, if you have a server, you just put it on a server, right? They don't. It's just another server. Where it's located is not important. Um, and so yeah, so that's going to be your. In order to get there, Then Apple properties display NEA's properties. Yeah, it's pretty typical. Creates a new external element. I don't synchronized exchange. It requires live document push pull. Okay, so it's interesting that you would be able to even push updates. So it's bidirectional, at least from what I'm seeing here. So I have not seen it like live because I'm not really familiar with that software, but that's going to be your to do basically from an infrastructure perspective, since and it's a good time to do it because you need your IT department to set up to give you a database anyway, or the database,
Mhm.
so like MySQL or something like that. So I would see if you can get a server and get them to install. You could just download it from the Sparks website, and just have them install the database. My recommendation, excuse me, is to put the ProCloud server, which is the software, right, just like a service on that Windows machine typically, to have that installed on the same machine as you put the database. Because what happens there was when you connect, as opposed to connecting through some ODBC, like I showed you yesterday quickly, right? You wouldn't do that anymore. You just basically connect to that server using a URL, and then their software manages the actual ODBC connections behind the scenes. So it's much more efficient. And so if the database is located on that same server, and they also use a caching mechanism, right, as part of that. So they do some active caching on top of whatever the database would do. So obviously it makes more sense, right, from a performance perspective, that if you have the database located on that same server as their software, it's going to work much faster. And you
Okay.
should actually see performance improvement as well, right? And that's no extra cost unless you want to have some other bells and whistles. Now for the integration, there is like I think it was, but it's like you can buy what they call a token, and I think it's like one token per integration, and it's like a very small. It's like, I don't know, $35 or something like that. Um, so it's probably no big deal at all, right, to get that. But that would be ideal, and it looks like you'll be able to pull Polarian stuff directly, and then we'll have to see how, because I don't actually show that here, but how the extra properties, right? How they would get mapped, right? Somehow Sparks would map them into custom properties, and you wouldn't have to customize the tool. It would kind of happen automatically. That's how it should work. I've seen it work with other integrations. So, yep, looks like
You,
you definitely have a path there.
you said you have seen it work with other requirements to
Well,
assess
other
that.
integrations, but not Polarian. I mean, yes.
Right, but like, does it work with like, I don't know, like Doors Next Gen or Jama? Like, have you seen Enterprise Architect link requirements to one of those other tools?
Yeah, like Jira, for example, right? Here's another one, exchange information from right Jira. So yeah, so that, I mean, Jira, that's a very common, right? A lot of people do that. Integrate with Azure DevOps. That's less likely, but this looks like they have a whole list of them. 30-minute tour. Okay, so let's see what else do we have in here. Integration plugins, right? Jira, Polar. Okay, here it is. Right, ServiceNow, SharePoint, Dropbox. Okay, interestingly, Bugzilla, Autodesk, and I think there's actually more of them, I thought, but this may not be a totally up-to-date list.
Mhm.
Yeah, Jira is, I mean, that's a very common one, right? So that's what I've seen people use most often. So it's more of a setup, right, an IT infrastructure just to get all the pieces of the puzzle. And at that point, once you get that ready, then you can just I think you have to buy like like a token, what they call a token for the integration. So you can look at pricing, see Pro Cloud Server, and then see like, okay, so 100. Okay, so I was wrong. It's about $100 per token, but a token is going to give you like an integration essentially. Um, and and then yeah, you could have like super configurations, but I for a small team like you guys, I don't think you're going to need um, like a 7 databases on the back end. I mean, maybe if you do one day, right? But I think you get like 2 or 3 databases for free, the first 2 or 3, and you could just integrate with that. So yeah, so that's the good news. So in that case, yeah. So your requirements, most likely they will not be quote SysML requirements, right? I would have to see the actual integration and the mapping that they do. If the tool allows you to select the kind of element, right, that you want to create when you do this integration, it's possible. I will need to see more details about the integration to tell you that. But I mean, if they'll definitely let you, decide what kind of element, right, that you want to build on the Spark side. Maybe they'll let you pick SysML requirements and be perfect. If not, if it's just worst case, it'll be like their own internal requirement. It probably doesn't matter, right, for what you're trying to do. And then and you, of course, you'd use the exact same relationships, right, in terms of just tying your other design artifacts directly, right, to the Polarian, to whatever the tool would create, right, that matches the Polarian requirements. So yeah, so nodes we talked about, but make them invisible. You could do that for the whole diagram or per individual element. Yeah, this is at the diagram level. So they kind of have the same options, right? So if I did like here, so when I have the diagram, right, I don't have any element selected. I'm just clicking on the background of the diagram. So therefore, on the property sheet, it's going to show me the diagram properties. Then you can go to compartments, and then you can enable nodes for the whole thing. Now there's no change probably because there are no nodes anywhere else. But if I did some, right, they'll start showing up. So, and that's pretty, common that, you can enable something for the whole diagram or for specific elements. And you should be able to also to do a multi-select and say, right, compartment. So you can select like 4 or 5 elements right on your diagram and say, okay, for those elements, right, I want to see compartment X, make it visible. And then requirement organizations, yeah, we talked about that, right? It's kind of has that containment hierarchy. This Polarian, by the way, have that concept where you basically have requirements that own other requirements, etc. Kind of parent-child relationships.
Yes, it does.
Okay, yeah. So the tool will be able to mimic that. I've seen them with doors, for example, integration with doors, where they mimic that hierarchy the exact same way. All right, so here's a couple of more like real life requirements with, again, right, refinement relationship with a master cylinder. I'm not sure about, in short vehicle. That's kind of a strange example here, but we have a power, right, the brakes up system, right, satisfies. So the way that particular block is implemented satisfies your master cylinder efficiency requirement, right? You can have decompositions graphically or more likely like this. And then derived requirements, right? One is specific test method requirement, and then a derived requirement that has to do with pavement friction. So just a couple of examples, right? More real life example, except this one is kind of a strange one. Top level requirements, right? Decomposition, again, you're not going to do that. But logically you are doing that, right? But in reality, you're doing it directly in the tool, not with relationships. And then derived, another more realistic example of derived requirements, right? Like braking has, regenerative braking as a derived requirement, or you could have, derivations can have come right from multiple. So let's say these are like your top level requirements that you got from the customer, from your managers, and then, right, you derive like the range, which would be derived from both the fuel economy requirement, fuel capacity, or the power that the vehicle needs. If you do design of a complete vehicle, right, it has to take account, off-road capability requirements, right, acceleration, cargo capacity, all of that's going to play into power. And then SysML also have some concepts like, problem statements, rationales that you can use. Those are going to show up. And I think SysML common. Yeah, so you have problem and rationale, right, that you can kind of add and say, well, let's say there's a particular problem with this allocate to, or just link. Either way is fine, right? And you just have some kind of a problem statement. That one should be directly. Okay, so it's again, it's one of those kind of elements that I mean, it's in the database, obviously, but it's kind of, it's hidden a little bit. We'll have to see when they generate documentation, right? You have to see if they actually pick up that automatically. I mean, obviously, it's going to be, if you take a picture of this diagram, or whatever you text you put there is going to be on the diagram. But sometimes it's nice to have something, right, that is like part of the more formal documentation, right? So I'm not saying don't use it, but I mean, maybe there's a better alternative than using these little, this is like a glorified note box, right? This is all that is. So I kind of have my own reservations about using these particular kinds of elements because they're not, to me, that they're not at the same level, right, as these other guys. Let's see, refine. Oh, that's like a state machine, right? That refines a requirement. So it could be an activity diagram, which is actually a pretty good example of refinement as well, where you kind of show the, at the top, at the high level, right, to show how a requirement is going to be satisfied. And it literally could be, I mean, it could be the refinement here. It could be a satisfy in terms of implementation. It's a satisfy, which I don't know, we don't have here. But if it's just some other model that you built that helps explain the requirement of what it's supposed to, or how it's supposed to be realized, then you can use a refinement relationship. So here's a couple of ways that you can add, or you can just right click as well using the, and say, new child element rationale, but they're just glorified notes. So just keep that in mind. And that's it for requirements. Well, I'm not going to do it an exercise. We'll spend time on exercises when block definition diagrams, etc. But because they're simple. I mean, you just drag them onto a diagram. Plus, it doesn't look like you're going to have to create them yourself anyway in the tool, right? If you do the integration with Polarian.
When you say that they're basically glorified nodes, you mean that like functionally they don't translate to anything but text, or what do you mean?
Yeah, well, in the sense that from a tool, and this is just a tool perspective, right? It's nothing about the spec. It's just that the way that they kind of, they hide these nodes under this little umbrella here, right? So it's like everything else that you put on a diagram, right? Like block 2, all of these things that they're on a diagram. I mean, I see them, right? I mean, they're like right away, they're here. Versus like when you look at the little note, it's like, oh, where are you? Now, I think if you do an Alt-G, yeah, they will actually, like you said, go find, right? Like we talked about yesterday, you say find in browser. They will go and point you to it. The interesting question would be like if I generate documentation, and we could take a very quick test and see what happens actually. It'll take a second or two. Well, it's giving me a hard time. Let's try it this way. So documentation, let's just generate something. I will pick their, let's say, model report, landscape. Yeah, nothing else matters. Temp. Okay, so just generate. So the particular template I picked is one that typically throws everything at the kitchen sink, right, in that document. So I just wanted to see if that note pops up anywhere.
Oh, okay.
So let's see, design. Well, I could probably design constraint. Maybe it's actually here 113. Let's find out. Maybe then it's not so bad. Of course, there's no real documentation here, right? But you see somewhere like the block, right? You see its external requirement, so it will actually bring in, right, the requirement that's linked to it. You see relationship. It's overly verbose, this particular template, but design constraint, derive, administrator, derive associations. What is this one? Design constraint, derive requirement. I don't think that's the guy actually. Oops.
Oh, okay.
Let's see, what did I put in there now? Oh, yeah, it's actually a problem statement. Oh, yeah, see, they're talking about this relationship here. All right, so that's not the guy. Oh, sorry, my bad. I keep hitting the wrong keyboard. Requirement 2, requirement 3, extended requirement test case. No, it's not in here. So that's kind of like, and that's what I remember from using this in the past, even with HTML, or it's like, yeah, it's kind of there, but it's not it's not really, see what I'm saying? It's not at the same level because it doesn't get picked up as, something like your diagrams, your elements. And that's my only concern. So, sometimes you can find, so that the trick would be to kind of look for something that you would use, and it may not be quote sysml, right? But see, the same thing, you're going to have the same thing with comment. A document artifact, that may be overkill, but that would be like a major, like a full like RTF, right? A full text document. Problem rationale, boundary, all of those don't use requirement, allocated. Is that another one of those? Yeah, probably, right? Yeah, it's exactly the same issue. So let's see under common elements if you have something better. Artifact would work. Otherwise, yeah, it's going to be the same issue. You don't want to do text boxes. So you maybe almost have to come up with something. Reading list, user story, document, governance, requirement change issue. Those, I mean, if you use, those as graphical elements, like, maybe like an issue, that would be like something that's going to pop up right here. Right? So that would be at that level. Otherwise, I think you're back to the same. So change, right? Change issue. That's, I mean, yeah. So within this space here, that may be, an option, right? Now, of course, I mean, you could, also say, well, I'm going to document the problem, directly inside this requirement, right? Now, as part of the nodes or as part of, like we talked about yesterday, if you use their maintenance issue, like, issues, defect, tasks, right? So things like that. If you show the task window and you could just, task is probably a bad example, but issues, right? Maybe, right? We should just, it's all the same interface, as you can see, right? It's okay, I'd create a new issue, which has a status priority, but all of that would pop up, right, in your generated document because it's literally considered part of the element. The only downside of using something like this is, let's say that there's a particular problem, which is kind of what we're seeing in this example here, where we had, so this was rationale. So this is also tricky because, again, it's going to be a node and it's attached just to a connector, right? But you could take an element like the issue element that I was just doing here and say, okay, right, you can see there's a little floating, remember, a little floating arrow, and you could just connect that, right? Say, I would just do trace, maybe, just do a trace. And then now you have a relationship, right, to that issue. So you can kind of graphically see that it's related to this. But the other problem is the situation where you have this case here. Oh, sorry, I keep doing this. Where you have a problem and then see it's connected to both power and fuel economy, right? So it's like, okay, so now you really can't hide it, right? But, or you have to copy the, the text on between the two. I guess you could do that. Or you have to find some element, right, that you can literally have, but something that's going to show up when you generate your documentation. And it's just the way that the tool implemented. It's not a specification issue. It's just the way the tool implemented these stereotypes, the SysML concepts, right, like problem and rationale. The way they implement them, I would have done it differently. But then, just to avoid that issue. So just something to think about. You could try a couple of different solutions, see what you like best. Probably.
Okay. Thank you, Frank.
Yeah, go ahead.
Oh, I just said thank you.
Okay.
Yep. And then I had a question on a different topic. I saw that you published and made a report. Are you going to go through how to turn these into reports? Or ideally, it'd be nice if we could export some of the drawings or the diagrams as like a PDF with like hyperlinks. Is that possible?
Yeah, I did show that yesterday, right? So if you just want to take individual diagrams, remember, right, through the publish ribbon, and then you could generate, you could either like print to PDF or, save as, right, save as an image, right, save to file, or just put it on the clipboard and put it on the PowerPoint or a Word document or something like that. So individual diagrams you can always, very easily externalize that way. If you wanted but if you wanted a full report like the one I did,
right,
yeah, then you're
right,
going to
right.
have to use one of their templates, right? Yeah, we're not going to have time to go through that.
Through the template creation. Okay, that was.
Yeah. I mean, they have a fairly decent set of templates, to start with. But yeah, more. I have no doubt that you need to customize them, make sure they have your heading, your footer, right, your copyright stuff, et cetera, et cetera. So that would take an extra. I mean, it's in their user guide, right? So it's not like it's not documented, but we're not going to have time to cover it in this class.
Okay, but it does keep like the hyperlinked elements. So if I want to be able to
Oh yeah,
have someone. Okay, that's good.
yeah.
That's good.
Well, it's on the HTML side, right? When a Word document, I mean, you really don't have hyperlinks, right?
But if you publish it as a PDF, does it keep them?
No. I mean, if you really
Okay,
want
so
it fully hyperlinked, then I think HTML is going to be your best option.
okay.
Yeah, because there's really no. I mean, I'm not saying maybe possibly they could do it. I know it's not trivial, but to keep all the hyperlinks, in a Word document, but it's definitely not a trivial thing.
Okay.
Yeah, because they just do a save as, right? They generate Word no matter what internally, and you've probably done this yourself. You have a Word document where you have hyperlinks, like from your heading, etc., and you do a save as PDF, and all your hyperlinks are gone, right? So it's like I said, it's not an easy thing to maintain all the hyperlinks. But yeah, with HTML, then you get a full. I mean, it's almost like you're in the tool. They do a pretty good job on the HTML side. So let's start looking at block diagrams. All right, so we already talked about yesterday, right? What's a block? What do you use it for? And it is like from in the structural part of SysML, that is going to be your key element, right? Because you can use it to describe, an overall system, like a complete vehicle, right? And you create a block that represents the complete vehicle, and then of course you can use it at the subsystem level, component level. In some cases, you can use it to document an interconnection. Typically, like on a case of it could be software, it could be hardware. There's some special cases where you can do that. You can use blocks to show, like for example, you could create a block called gasoline for a gasoline vehicle and show how that gasoline makes it through the fuel system. But it can also be used for external things like environment, like the weather conditions, or the road conditions, or with sensors, right? Other vehicles on the road that your sensors pick up, anything like that. Could be complete abstract entities, right? That you're using at a top level. So that's going to be your main building block. And just like in any object-oriented concept, which this SysML still is, right, based on object-oriented concepts, the block is like a definition, right? And then you're going to have instances, right, of that block that are used right within the scope of the overall system. So in that sense, it's similar to UML. So blocks are going to have properties, or at least some blocks, not all blocks. You may have some blocks that don't, but most blocks will have some properties on them. And the properties themselves may be defined by another block, right? So you have sometimes you have properties that are represented by data structure, right? You have half a dozen different properties, right, that make up another property. And so that particular description, you can use a block for that, right? And that would be like a struct in C++, for example, right? You'd use a block for that. You have features, right? Things like functions, like for software, right? Or software firmware, I guess you can model that with operations. And then of course many other things that are not shown here. So to break down logical or physical aspects of a system, that's going to be right your top. Well, you have when you use a block just to describe some data structure, maybe generally it doesn't get broken down, but the blocks that really represent, the high level concepts of something, right? Like for example, a vehicle, or, an airplane at a very large level, or just a compressor, right? Um, all of it, right, is going to be at some point, from a pure hardware perspective, right, you're going to start taking it down, deconstruct it. In the software world, the same thing may happen, right? You may look at, you could use a block that represents an entire set of functionality that the software provides, but then you can break it down right into sub functionalities, right, just like we do in traditional software components. So the whole breakdown concept could be used both hardware and software level. And then we already talked about that, blocks. And then you use a block definition. This BDD stands for block definition diagram. So that's going to be your main, the key, right, diagram that you use for these particular, to model these elements. And then once we look, if we need to look inside a block, some blocks you really don't care what happens inside, but especially on the hardware side, if we do need to decompose it, kind of open the box, right, and see how it's actually built inside, or what all the different subcomponents are, then is when we're going to be using a different diagram, which is like the internals, right, of the block. It's called IBD. So properties we talked about. Ports we're going to talk about a little bit later, but for now, just think of a port as like if you define a block, and that block is whether hardware or software, doesn't matter, and that is going to interact with other components, with other parts of the system, then for it to do that, it's going to need attach points, right? It needs like connection points, right? And so the concept of port, which again is used in UML as well, but here a port can literally be like some physical connection. Like if it's a mechanical, right, connection between two devices, it could literally be like something you need to screw on, or that you need to you have some kind of connection point, right, physical connection point between two things that you need to attach to one another. Could literally, right, be a physical thing, or on the software side, it could be representative of like port 443 or something like that as well, right? So it's very versatile concept, but in all cases, what it represents is an attach point through which communication happen with something else, right? Whether it's physical communication, whether it's bits and bytes being transported over, let's say, a USB connection or an RS-422 connection, doesn't matter, right? So you need some connection point, right, for A to be able to talk to B. So we're going to talk about ports probably later today or tomorrow at the latest. And then of course you have relationships, right? So you have connection points, and then the relationships that go between the connection points. Now in the block definition diagram, the only thing again is a definition diagram, right? So remember that. So you're not really showing how one port connects to another port on a different component. That's going to be in the internal blocks. This is where you actually see the wiring. So if you think about a wiring kind of diagram, again, hardware or software, then think IBD. Here, all we're doing is saying, okay, this block has this set of properties. It has these 3 connection points, right? It has these 4 behaviors. That's it, right? And then if there is a relationship between the block, we just create a connector that shows there is some kind of relationship, but the actual, how that relationship is going to work, that we defer that to the IBD, right? So, and then, yeah, we don't need to worry about that. So a block's going to have compartments, many different compartments, graphically speaking, right? In the sense that on any diagram, when you represent a block, you'll have choice to say, how much do I want to like show, right? How much of the details of that block do I want to show? Like the requirements, right, satisfied by a block. I think we saw an example of that. Satisfy here. Yeah, so for example, here, if I said, I wanted to go to compartments, and what you'll notice is, well, that's interesting, because it actually should show me something more than what it's showing here. So for SysML, what the tool usually does okay, is that they'll automatically start showing you more choices, right, in compartments based on the actual model. And so if I do this again, see, they should actually show satisfy. That's interesting. Let's see if it shows up on the diagram side, because I'm supposed to be able to show in a compartment here that this particular block satisfies this requirement. Let's try it from the other side. Let's see, compartment visibility, nodes, tags. Interesting. I have to find out why that is not working the way it used to. And properties. Okay, let me move this guy out of the way. Scenarios. All right, well, I'll figure that out a little bit later. But so some of these, so built on our relationships, like for example here, I should be able to see on both sides of the fence, I should be able to see that this test case verifies this requirement. Oh, you know what, it could be because this requirement is visible. Because if the relationship is visible, then if you show it again as a compartment here, it's kind of overkill, right? So that maybe have something to do with it. So I just graphically removed it and see if that's what and see that may be the reason. Nope, still not. Okay. Weird. Visibility. Okay, here. Okay, here it finally showed up. So it verifies. Okay, so right, so you can. So that's a compartment. So if you put this test case in a diagram, that the requirement that it verifies happens to be not graphically represented, like is the case right now in my diagram, supposed to be able to show that. And the same thing on the block, it should actually give me that option. Oh, here it is. So it's just like a refresh issue. All right. Right. So in some diagrams, right, where the block, because like the requirements, we already talked about that. You almost never show them on a diagram, right? Here we're just playing around. But then when on some diagrams on the detail, right, for some of the blocks, then it's nice to see, right? Oh yeah, this particular block, right, here's the requirement that it satisfies. And conversely, if I created another diagram, I put requirement 2 on it, I would see that it's satisfied by block 2 and it's tested by, right, this test case. So like that's, and again, you see the tool is literally dynamic, right? So they have a set of compartments that are always there, which are always available, right, for all elements, not just SysML. But then on the SysML side, they start adding things on the fly. Sometimes you need to like, kick them a little bit in the butt so that they refresh their interface. But these things will start showing up as they become technically available. So they look at the diagram, say, oh yeah, there are some satisfied relationships, and then they'll make these things available. So that's pretty neat. So properties, right, can be shown in a compartment, like the actual functions, right, or signal receptions, constraints on a particular block that it has to satisfy. Namespace, I'll show you examples of that, but it's rarely used. That would be like showing some of the details of the block inside the element, which takes up a lot of screen real estate. So you rarely do that. Allocations we'll talk about tomorrow, right? But the requirements, and then structure to display connectors, yeah, other internal installers. So here's an example out of the spec. You kind of see all the possible compartments. And so for any given diagram, you have control, right? Like for this particular, because every diagram kind of has an audience, or at least has a particular meaning behind it. And then you decide how much do I want to show on this diagram, right? And there's actually way more compartments than is even shown here, right? But things like parts, properties, like references to other blocks, like connectors to other blocks, properties that are specified with value types, which we'll talk about as well, as opposed to just like, primitives, and then function calls, right? And then receptions for asynchronous signals, like sensor information. So, and then things like the actual behaviors, like activities, right, that the block performs that you could show in here. It's like big list. So this is kind of what I was showing earlier, right, that the tool will look at the diagram and say, okay, well, you have, right, these are your options, right, that you can make visible or not, right, again, totally up to you. And let's see if there's anything we haven't talked about. No, that's fine. So we looked at a similar example like that a little bit yesterday, right? So I'm just going to go back and give you some of the terminology. So this is really the key thing from a terminology perspective. So the relationship here, like when you start decomposing a block like the anti-lock controller, the relationship here, these are called part associations in SysML. And UML, they call the same connector with the black diamond, they call them composition. So that's why you see the term composition. And then when you model it that way with a black diamond, right, they're basically the parts. So whenever you create a relationship like that, right, because it's a decomposition relationship, right, that's its purpose. What you're really saying is the anti-lock controller has, the way this is modeled here, right, has two parts inside of it, right, internally. I mean, whether it's physically inside or not, but it has two parts, right, two components that it owns. So in other words, if you remove the anti-lock controller from your design, you don't need it anymore, or you have a vehicle, let's say, that doesn't have ABS, then these guys would be gone as well, right? Because it's literally part of it. Whether it's physically contained or not is not important. So they're owned by the block, right? And then you could show multiplicities. We'll talk about that in a little bit later. I always do, because I never leave them implicit, right? But so in other words, multiplicities meaning what? Well, how many traction detectors are part of an anti-lock controller? So, well, obviously there's only one. Well, okay, maybe in some cases it's obvious, and maybe in some cases it's not obvious, right? Or maybe it's obvious to one person and not to another. So I know I'm in the habit of, I would always put a one there, right? Or whatever it is, right? Could be two. Let's say that an anti-lock controller could have, or it could be, one or two. Maybe there's one configuration where the anti-lock controller has two break. I'm making something up, right? And then it could be one or two, right? So by making that explicit, then you don't, because otherwise, if you see it like that, it's like, well, did the person who created the model, did they just forget to think about it, or would they, is it really one, right? If you put one, there's no ambiguity. So that's essentially what that means, is that it has a part, which is a traction detector part, and it has a part, in this case, right, one of each of a brake modulator part. That means, and then the name of the part, if you put some label there, which you don't have to, but it's not a bad idea. If you put some label there, then because there's only one, it will say, well, the name of that part that the anti-lock controller owns is D1, right? Like D1. It's pretty cryptic names, but you can be less cryptic than that. And then a modulator, right, an M1. So when you then decompose this into an internal block diagram, right, you're seeing D1. So, and by the way, the tool, as you build this connector, the tool automatically creates the part, right? I'll show you that in the tool. So that's their responsibility, right? So you do the decomposition, and the BDD, they have to create the parts that correspond to that. If you delete this connector later, you change your mind, then they'll say, hey, shouldn't I delete the part as well? And typically you would say yes, right? Then you shouldn't keep the part. But so they'll create the parts, right? They'll look at, see if you put a label there, they'll label it automatically, D1, right? Traction detector. So now to this part, which is a separate element in the database, right? You have the block as an element in your database. The parts that are created as the result of you doing that decomposition, of course, are separate elements, right? And each one will have the name, or could be nameless if it's not important. Just like the object, right? I showed you yesterday when we did an object of, I think, a block, right? And it had no name. Then it's the same concept. You can name it or not name it. And so then the tool, right, knows that there's two parts. When you create the internal block diagram, you just right click on the diagram, you say synchronize, and automatically bring in these two elements. And after that, right, you could add the details. So here what they're showing, like, we'll see these little guys here, right, these little squares that sit on the boundary, right, of these things. Actually, for those little squares to pop up, that means that both the traction detector and the brake modulator had a port defined, like we talked about here, right, a few minutes ago. So that's one of these interaction points. It's just graphically how they're going to show on your diagrams. They're going to show, like, these little, whoops, what happened? Oh, there we go. These little squares, right? And then depending on what you define the port to allow, what actually is allowed to the port. So think of the port as like, it's almost like a door, right? So to say, okay, I have the concept of a door, and then if you have a door, if there's no door, there's no way to get to anything, and there's no way to connect to the thing, right? So you put a port there, that means there's a door, but the door can specify, or should specify, who's allowed to open it and what you're allowed to do, what you're allowed to either request the traction detector to do, or what the traction detector is allowed to do if it's communication both ways. In this case, it just goes from from the traction detector to the brake modulator. So on this particular port here, you'd specify that here's here's what the traction detector, right, is allowed to do through this particular interface. These things are called interfaces. So you put an interface on the port that says what actually is allowed. So it's not like, you have a door with no key on it, right? I mean, you can do it that way, which is like an open door. Anybody can come into your house, right? Or you could be more precise and say, no, it's, the key here's, you have to have the right key, and the key is the interface, right? And anybody who has the interface, the proper interface, that's what they're allowed to actually, right, invoke, have me do something for them, right, based on that key. So that's going to be the interface. So these are ports, right? The little squares, the bigger rectangle here is a port, which is always an instance of a block, right? So definition captures properties, etc., right? And then the usage, right? The usage of this. So this is the definition, and here are the internals are showing how things are used, right? So the usage of a block in a particular context for a particular purpose, right? Does that make sense a little bit?
Yeah.
That's to me.
Okay. So there's a couple of examples here. We're going to show you a number of examples. Not all of them. Most of them come from the automotive domain, where you have kind of a more abstract view of the world. So you have a block called automotive domain. Well, that's like very, very abstract, right? But you could say, well, within the automotive domain, I'm going to break that down, and things like, I have a block that represents a hybrid SUV. But there's also things external to the vehicle, like baggage, passenger, driver, right? I mean, you probably never model passengers and baggage. Well, probably, but the driver, yeah, it makes sense, right? The driver is going to play a role in what the vehicle does. So you could have a block that represents a driver. And you could have a corresponding actor, right, in a use case diagram that represents it. In the use case world, you'd have an actor called driver, and in here we could have a block that also represents the driver, right? And then this is again like a generalization, inheritance relationships. You have the concept of a vehicle occupant, right? And there's two specializations, where the passenger and the driver, right? And of course, the driver is allowed to do things to the vehicle that passengers ideally shouldn't do. On the other hand, you have things like the physical environment, but again, an abstraction. But I have underneath that abstraction, I have concrete things like, okay, road conditions, right, with the incline and the friction, which sensors what pick up from the road. You have external entities, other vehicles, like traffic lights, etc., animals on the road, whatever right, the vehicle can detect. And then on the atmospheric condition, which may have a huge impact, right, on the performance of the vehicle. Air density, temperature, amount of dust in the air, things like that. So, right, you can kind of see there's again things that sensors, right, can pick up, and then each one of these values can at some point influence, right, how the vehicle behaves. So these are just little examples, right? So you see the use of very, very abstract, right? The block has a very abstract concept, but that abstract concept gives you then the base for to say, okay, so under that umbrella, right, what are the different things that fit, what are the parts of the environment that could impact the vehicle's behavior? So fairly high level, but still kind of an interesting, and it's all of these are decompositions, right? So here again, I did, I did not put the ones, I mean, because that's kind of my own personal, um, you know, um, inclination, right, to always put multiplicities there. But from I teach, I'm not trying to impose my own personal, preferences on people. So, here it's basically if it's not shown how many there are, then it's just a one, right? So it's kind of following the system convention. But if it's anything other than one, of course, you have to specify it, right? So you may not have any baggage. Then we could say, well, in this particular automotive domain, we're only going to go up to, vehicles that could support a maximum of four passengers, for example, right? And then, the vehicle may have a driver in it, or it may not, but there's only one driver. Military vehicles, of course, is not necessarily one, right? You can have more than one driver in a military, like in a tank. In a physical environment, right? You have one, you're only driving on one road, right? You have potentially, zero to many external entities, and again, there's only one atmosphere, right? So you kind of see that, you could model it that way, leaving the ones off, and then, but definitely make sure that if something is not one, that is obvious from your model, right? That you're dealing with a collection, an array of things potentially. So that's kind of very high level view. Now we're going to look at kind of another side of the coin. Still the same kind of. Yeah. Uh-huh. So what? So things that are part of. Give me an example of. Uh-huh. Go ahead. I lost you. Go ahead. Ishwar. Mm-hmm. Oh, in the same diagram? Yeah, I mean, it's up to you, right? So the diagram is just a context, right? Obviously. So, you could, I mean, whether you show it or not. Yeah, I was going to say, if it's relevant to you, then you put it on the diagram. If you feel that it's not relevant for this particular, so here the context of the diagram is external environment, right? So it's kind of looking at the vehicle and say, well, what are all the things kind of outside of it, right? Sort of like passenger drivers and roads, etc. So that's the context of the diagram. So in reality, you're going to have hundreds of blocks, right? That like the detail of the hybrid SUV. So how much do you put on this specific diagram? Well, if it's relevant for the context of that diagram, you throw it on there, even if there's no, I mean, you could throw things on there that are not connected to anything as well, right? It just, in this example, everything has some kind of relationship with something else. But if it made sense, right? If you had a block that you say, well, it is part of the environment, but it doesn't connect to at least anything else on this diagram, that'd be fine as well, right? Well, Well, remember, use case is a behavior diagram. This is a structural diagram, right? So this is the decomposition at the structural level. What are the concepts, right? And the components that will make up my system. The use case is a behavioral diagram that describes how, specifically in the case of a vehicle, how the driver would interact with the vehicle, right? So all your or the driver or a mechanic or technician, but it's in the case of a vehicle, it's always going to be right some human being typically, right? And that's your use case model, is to say how do I use my system of record, my system of context. That's what the use case. So the use case focus on behavior, right? That's what a use case diagram does. This does not focus on behavior at all, right? It's just pure structure. That makes sense. That's why I kind of see that the concept of driver here, there's a corresponding concept of actor, right? And so we'll see tomorrow when the use case model where we have some examples of the driver, right, interacting with the vehicle. I think in your world, you guys don't build necessarily like full-blown systems that the driver, I think, was directly exposed to, at least in some cases, right? The actor on your end may just be some other component of the vehicle that you integrate with, right? So in that perspective, it's external to your system of design, but it plays the role of, right, it's external. So if it's external, then you would have a block that represents whatever that other component of the vehicle is that you, right, connect to or integrate with or fit into or whatever the case may be, right? But it's the same concept, right? Absolutely, yeah. If you'll be, I mean, not probably not passenger and baggage, right? But for the driver in some cases, yeah, for sure, because like, in my activity diagrams, right, are going to actually, that derive from the use cases when I start building my activity diagrams. A lot of times the swim lanes that we talked about yesterday, right, they're going to represent like the driver, because it's the driver that's going to give an impulse to the vehicle, right? It's the driver who accelerates. That drives an event into my, right, with software, firmware, hardware, whatever, right? But that's going to drive a whole set of things that happen in the vehicle. But the initial event, right, um, comes from the driver. So I mean, you could put it, you could tie it directly to an actor, but sometimes if you're interested in maybe some of the properties of the driver, it may not be in a commercial vehicle, maybe not so much in a military environment, for example. The drivers have a set of permission. So depending on the rank, right, where some like a commander, when a commander drives a military vehicle, he has way more things available to him or to her than, let's just say, one of the soldiers who happen to drive the vehicle when the commander is busy doing something else, right? And the vehicle knows, right? So it needs to know that who's actually driving. Is it the commander? Then I'm going to give him way more options, etc. So in a commercial vehicle, it probably doesn't matter. But you may have cases, right, where you have properties that say the permission set, maybe the mechanic, right? Sometimes on devices, when the mechanics or the people that maintain these systems, right, they're allowed to do a lot more in terms of like doing software resets or downloads or software updates, right, or things that that as a regular user you're not allowed to do, right, on certain devices. So it's the same concept, right? It's an external entity, but it may have properties that allow it to do perform certain behaviors based on, right, or on some property that's part of it. So that's why it may be useful, like in this case, to have a block, right, that represents some of the driver's abilities, for example. Okay. So let's look at a kind of an example now, way below, right? So we're going from one abstraction layer to another. So now we're looking at the wheel, the wheel package of a vehicle. And so I have things like a wheel hub assembly, right? The actual, which decomposes into a wheel assembly, into all the lug bolt joints on it, and into the hub as well, right? So, right, but it's the exact same. It's the same principle, right? So when you're doing the decompositions, for mechanically, you're going to do a mold exactly the same, right? You're going to specify multiplicities. Probably more important at this level, right? So you have like, there's two tire beads, right? There's two tire mounting rims, right? One inflation valve, up to 6 balance weights, just things like that. I mean, it's a made up example, right? So I'm not saying that, that's exactly how a vehicle works, but, you're going to have, so the wheel hub assembly, here I'm showing you when you do this decomposition. So when I build this connector here, let's say from wheel hub assembly to wheel assembly, remember the tool has to create a part, right, as the result of that. And so then the part, I'm actually showing the part, right? Typically, I either show it graphically like this, the decomposition, or I'll ask the tool to show me the compartment, one of the two. But here I'm showing you both to make it very obvious that it's you building this relationship that automatically creates a part for it, right? And I see, for example, when I put the number 5 there on this relationship on this connector, say there's specifically 5, right, lug bolt joints, then you'll see that number repeated here, right? So this is kind of a showing it both ways, which is overkill, but just to, again, to re-emphasize that there's a direct relationship, right? The parts that the tool will create directly corresponding to. So all of these here with the black diamond are all decomposition, right? The wheel assembly decomposes into the tire and the wheel. Do I have any more? Yeah, the wheel decomposes right into these three guys. The tire decomposes into the two tire beads, etc. And then you also have like, so decomposition, think of decomposition as like a vertical drill down, right? It doesn't matter whether it's, in this case, it's actually horizontally graphically shown, but logically, right, it's like a vertical drill down. I'm opening the box and I look at the top parts and then I look at the parts underneath and I keep, right, pulling stuff out of the box and seeing how things are built. But then you also have just, relationships between components that are horizontal, like, between the threaded hole. This is like physical connectivity here, right? And the lug bolt joint, I mean, one does not contain the other, right? There's no decomposition between the two, but they are connected. There's literally a physical connection there, right? So same thing between the lug bolt joint and the mounting hole. Here's between the tire bead and the mounting rim, right? So these are the two main relationships. There's some other ones that we'll use as well, but the key ones, right, you're going to use maybe 95% of the time is going to be part association. That's this connector here is going to give you the black diamond. That's your decomposition, like vertical kind of decomposition. And then if it's just relationships between two components, but there's no hierarchy between the two, then you just use a reference association. That will look like this. Right, so one is going to have the diamond, the other one is going to just look like this. Now, some of these properties here, as an example, I put a like a mount tire. Maybe there's a way to automatically mount tires on that thing, just as an example. But you're also going to see some here, like for example, on the wheel, I have a diameter which is measured in millimeters, right? In this particular example, or the width, So when you say, let's see, like it's like, where does that come from, right? So that's going to be when in the SysML you use value types, and I mentioned briefly some of the value types that are defined as part of the SysML, which is like real number and integer and boolean and and string, I think. But in real life, right, you guys are going to come up with your own sets, right? So we'll talk more about value types and how you can define them. But things like torque or pressure, right, measured in psi, right, or pound or torque, right, it can be. So that's why you start seeing that this would be in your library, right, these value types, because they'll start using them all over the place. And then when you have a property on something, what's a physical property or not, right, and in this case they happen to be physical properties, right, then you basically have to give it a data type, right, to say how do I measure, what's my unit of measure, right? If I say lug bolt size, I mean, you could just put a string there, but you really should define, like, what the actual unit of measure is. And so this is what the value types allow you to do. So now there's no ambiguity, right? You know exactly how you're going to measure that, whether it's inches or pounds or whatever. So here's another example of using PSI, right? Tread size, lug bolt size. So a kind of combination of, right, decomposition, which automatically the tool translates into the parts, but the tool will automatically create those for you. And then of course you have to add, right, the properties, that are required as need be, and assign them, right, some kind of data definition. Does that make sense? Okay, I'll take that as a yes for now. Here's another example, very different context, but again, just a camera decomposition. I don't think there's anything too special from what we've seen so far, right? But just to show you different context. And again, here I'm actually, this is the way I would model it, right? I would put my ones everywhere. But you'll sometimes also have a case, for example, where you have, like, the mount assembly has has an azimuth motor and an elevation motor. It's literally the same, like the same part number, right? So like from the same vendors, like one part, it's two motors. Let's assume that, right? But it's just used for a completely different purpose, right? So the purpose as an azimuth motor is an elevation, but it's the same motor, right? So then the question is, well, if I model that just with one, like I think up here, with one connector, and I say two, right, two motors, you're not really conveying, the usage, right? The fact that they're actually used differently. So in this case, I would actually explicitly then say, right, I have two connectors because each one, because there is one azimuth motor, one elevation motor, as opposed to just doing one connector with a two, right? So I think this is much more representative of reality than the way this is modeled, right? I think the other ones are all tilt. Yeah, these are all okay. Also in terms of labeling, right? In this case, I mean, it would be very important that you label, because if you took off the text azimuth motor or elevation motor, I mean, you'd see that, yeah, there's two motors in there, stepper motor module, but I mean, what's the purpose, right? So it really conveys something. Otherwise, you don't necessarily have to put labels on these things, except when they add, meaning. Like here we have an elevation gimbal and an azimuth gimbal, right? But they also happen to be, they're not the same physical components in this case. So they are two separate blocks, but again, you add the label there to make it clear what it's used for. Other than that, nothing special here. Okay. So what we're going to do now is give you guys, get you guys on an exercise. But first, before I do that, I'm going to have to show you the mechanics in the tool. All right, so let's play with this a little bit. So I'll just use, I'll keep adding into my little example here. So from a exercise perspective, once you guys do it, I want you to go to open up right the test, the exercise database. You're going to go under SysML training. That's the root node name. Then look for structure and behavior exercise model. And this one is just exercise 1A. Yeah, exercise 1A. Right. So I'm actually showing you what you should be looking for. I think I pre-created the diagram showing parts. Yeah, I think either one is fine. I also pre-created a little note, so you don't have to type that in. That's the only thing that's given. The rest of it you have to create. It's a pretty simple example, but the focus of this first exercise is on the tool mechanics, right? How you actually build these things. So actually, no, let's go back here, and then let's just say I have this particular block here, right? That I'm going to decompose into two other blocks, right? So let me switch back to the BDD thing. It is a BDD, but I temporarily switched the requirements here. I can take all this other stuff off just to not clubber the diagram, right? Okay. So I have my block 2. Let me switch again. So somehow block definition. Right, so you're going to take the blocks, you're going to put it on the diagram. Let's just say that block 3 is a part of block 2. All right, so how are you going to model that? So if you go part association, now there's a bit of a trick from the tools, but well, not a trick, but it's just a constraint that the tool has, that when you use part association, if you're going to build it from the toolbox, like we talked about yesterday, you have to build it. So you want the diamond to be on the block 2 side. In other words, it's the block 2 that's like the container, right? And it decomposes into, well, do a block 3 and a block 4, right? So therefore, the diamond has to show on the block 2 side, right? Because that's what you're decomposing. So if you want the diamond to show up on that side, you have to literally start, when you build the connector, you have to start from block 3 going towards block 2. It's like you're going from the part right towards what it belongs to, where it goes into. And then why is it doing that? Not that's absolutely crazy. Block. Oh, wait a minute. Is that? Oh, that's the block that I remember yesterday. I was playing with that and showing you that underneath the covers, this is a UML class and not a block. That's why the tool is confused. All right. So let's fix it. Right? So we can go back and say that it really is a block. So we took this stereotype off yesterday. Right? Okay. So now it shouldn't complain anymore. All right. So here we have the relationship. Now here's some interesting aspects. Again, this is all tool stuff, right? So first of all, we see that the tool automatically, when I do this, I wish they didn't personally, but that's their, that's what they do. It is what it is. When I build this relationship, they automatically start showing this compartment, which is kind of crazy because I'm seeing this, the part is really already graphically visible, right? But anyway, so as you build up the diagram, you could turn that off, of course, right? It's just a compartment. Sometimes I'll turn it off for the whole diagram, but I'll do it later right now. So if we actually look in the browser, what happened, right? See, and there's a part there called block 3, right? So as it is unnamed, why? Because I didn't put a label on that side of the relationship to give it a name. And again, you don't have to, right? Unless, like I showed you, there's some, right? It helps understand what you're trying to do. So this element in the database got automatically created, right, as part of this relationship. Now, if you look at any of the examples I was giving you a little bit earlier, right, you're supposed to see there's supposed to be an arrow, at least according to the spec. If you guys don't put the arrow, does it matter? Not really. I mean, it's just, but technically, right, if you want to look at any example in SysML, they'll always show you decomposition with an arrow, right, showing that this, so the arrow basically implies that the containing block has, of course, direct access to any of its parts, right? You don't need to do anything special. It's like, these are my parts. I can ask them, I can control them. I can set their properties. I can invoke any behavior I want because I'm kind of the owner of this thing, right? These are my babies. So when you do it in the tool, however, it doesn't show the arrow. Like, okay, is that a big deal? Yes or no? What happens is, if you remember from yesterday, when you build a relationship in the tool, we said, well, when we go from A to B, we want the arrowhead to be on the B side. Well, here's the interesting part. The tool forces us to go from, in order to get the diamond on the right side, they force us to go from block 3 to block 4. Well, I'm sorry, to block 2, which then means that actually underneath this black diamond, there is an arrowhead, right? But of course, it's going the wrong direction. So because it's the default direction is source to destination. So then if you come in here and you say destination to source, but you reverse the direction, then I'm going to see my arrowhead. All right. So it's kind of annoying. I actually have a little script that I can show you that you can build your BDD, and then at the end just run the little script and automatically will flip all these arrows around for you, because I got tired of doing it manually. So that's one thing. Now let's say that we actually want to say, okay, how many instances of block 3 are there? And let's also assume that we want to put some label, right? In some cases, you will want to put a label there to identify kind of the part, the role, like the functionality of that part within the overall system. So the connector itself has a property sheet, right? It has actually lots and lots of properties if you start looking at it. But there's only a certain subset that we're interested in. One is what the direction. Of course, sometimes you want to change the style. We talked about that yesterday. Here, now when we look at so there's really, why are there 3 tabs, right? Well, because you have the properties that correspond to the entire relationship, but then you have the properties that correspond to each side. It's a binary relationship, right? You have properties on one side and properties on the other. So if you look on the source side, right, the tool looks at block 3 as a source, which is correct. Why is it the source? Has nothing to do with the arrowhead. Is the fact that when I built the relationship, I started from block 3. I went towards block 2. So, regardless of where the arrows, or even if there are no arrows, because not every relationship even has an arrow on it, the tool will always consider block 3 the source, because that's how I built it. And so if, in this case, if I want to now add, let's say I want to define the multiplicity to say, oh, there's one, there's one part of type by block 3, or there's 5 or 10 or whatever, right? You have to set it in the multiplicity on the source on that side, right? And if I want to put a label, I'll just put, I won't be creative here. I'll just put something like B3 as a label. Then I would put it here, right? So here's where the text would go, and here's I would set my multiplicity. The tool will give you a drop down, which is like commonly used multiplicities. Some of those have mean the same thing, like star and 0 dot dot star means the same thing. It's like historically from UML, some people like to use star, some people like to use 0 dot dot star. I always use the numeric, just again by convention, right? There's no right or wrong, because it literally means the same thing. Like here, like 1 dot dot and 1 dot dot star means exactly the same thing. But so these are like predefined ones, because they're very commonly used. Like the 1, right, is what I would pick in this particular example. But let's say that it could be either 1 or 2. Right, maybe depending on configuration, I could have 1 instance of that part, or I could have 2. Right, then how would I model that? Right, so this is a combo box, so you can literally, like, following the same conventions, right, in terms of specifying multiplicities, I would just say 1 dot dot 2. Right, or if the part is optional, I may have, maybe it's a case where I could have not have the part, depending on, again, configuration, or it may be there. So I would say 0 1 dot 0 to 1. Right, or if I could have an array of these, I always have at least 1, but it could be 1 up to 4, right? Then I would do that, something like that, right? So you kind of see here, and they'll put the labels right over the little, so this becomes like the name of the relationship. The tool then now automatically, right, put the label here. If you look in the database, they automatically updated that, because this end, this part, if you will, of the relationship, this side of the relationship is literally what controls, right? If I change this to a different block, if I change the name of the block here to block 32, right, it will be, well, once it hasn't refreshed yet. Let's see if I reload. So sometimes it takes them a little bit of time to refresh things. So even here it still shows as block 3. It's kind of interesting. Like, see if I generally a reload would do it, but it doesn't do it in this case. So you'll eventually, sometimes you'll run into that where it's a little bit stubborn. If I close the diagram completely, reopen it, see now it did it. Right? It's like it's kind of funny because I did a reload and a close and an open should be the same thing as a reload, but I guess there's a difference, right? Now it still shows block 3 here. Right? So that's one of the issues with the tool sometimes is like a lag until it refreshes. At some point it will refresh, something will trigger it to refresh. If I actually reload the package, right, just basically saying go to the database, right, and just refresh my memory, my view in memory, because in the database it is correct. It's just a refresh issue. And now I go back and look at block 2. Right, so it says block 32. I know it's correct in the database, but it's just what they show you in the browser. Sometimes there's a time lag. All right, so that's going to be from an exercise perspective, right? So you know how to create it. You can actually create it. Here I did it from I use part association, right, from the toolbox. You guys can also do it like this, right? I can say, but here it will not say. Remember from yesterday, right? It will not say part association. It uses the generic UML terms. So in this case, you would say aggregation to I'm sorry, composition. Right, composition to whole. You would have to pick this option to get the exact same connector. So here's some screenshot, which how to. So it's on the source side, right? You set the multiplicity in this example, and just let's build this particular breakdown here. So you have so there's a couple also of regular relationships, right? Like for example, between the power subsystem and the wheel hub assembly, right? It's going to drive, right, the rear wheels probably. And so in this case, right, it's going to connect to 2. So you see a relationship. So in that case, you're not using decomposition, you use reference association, right? And reference association is, let's actually do another one here, block 33, right? So here I'll use just to show you, right? If I say composition to whole, right, it will. And again, I did not put any multiplicities yet or anything like that, but it's going to look exactly the same. So either way you get there, let's just say that those two parts also communicate with one another, right? So let's, for example, say that block 32, that component, it needs to connect to block 33 mechanically, electronically, it doesn't matter, right? So it has some connection with that, then you would use a reference association here. So that one is simple. You just go from the side, right, from the A to B. If the connectivity is bidirectional, maybe it's some kind of USB connection or RS-232 connection, and they literally talk to one another software-wise, then remember from yesterday, right, you could do bidirectional. So if I change it to bidirectional, I save this relationship, right? You see the arrow go both ways or just one way, but that, from that perspective, it's a little bit easier to create than these part associations. And here again, technically speaking, well, okay, so here's another tool quirk actually. So let me put it back the way it was. Because there's an issue with bidirectional, something that they're supposed to do that they don't. So I'm going to go back into the source association. Now let me reload the diagram again. All right, here we are. See, so when you create a relationship like this, right? Again, that means that there's a part, even though it's not owned, right? But there is a part typed by this particular block, whatever that would be, that is referenced, that is used, if you will, right? It's not just reference. Here they call it reference, but think of it as it's using a part, right? That this would be. Maybe this is a power supply, right? Something like that. So it's using that part. That means that it has an instance of that part. So the tool again has to do, right, what you expect it to do, which is it has to create a part for block 32, but which is defined by, right, whatever block 33 would have in terms of properties, etc. So it does that. Now, well, what happens is, let's say that you look at this and you say, well, wait a minute, it's actually it's a bidirectional connection, right? So block 33 will also maybe request values for block 32, or it will ask it to do things, or it will just pass some kind of power connection to it, whatever, right? So there's something going on both ways. So then you think, okay, so what I need to do here is just change it to bidirectional, right? And we're done. Well, there's a problem now, because even if I reload my diagram, the tool has not created, so now it needs to create a part here, right, that points to block 32. Well, they're not going to do that. It's like, okay, I filed it as a bug, and they told me what's not a bug. So, okay, so that's fine. I'm not going to argue with them. So what you have to do in that case, right, just to get around the tool's limitation, is to basically say, okay, I'm going to have, if it really is bidirectional, right, what you do is you do a reference association both ways, right? And so now if I reload, I force it, right? So now I get what I want. It's kind of silly, but I mean, I kind of understand, because the fact that you change the direction here in a property, they don't have that as an event internally, right, to kind of drive the creation of the part. But still, I mean, I think they could be smarter about it. But anyway, it is what it is, right? They're not gonna change their software just because I complain. So that is for bidirectional, right? Just you go both ways, and then you get the reference that you need. And so now if we look, right, we have block 2, right? Block 32 has a relationship here. Block 3, right? We see the parts being created. So from an exercise perspective, you're going to have 2 of these, right? So here the brake pedal, the physical brake pedal, is part obviously of the brake subsystem, so it owns that brake pedal. But the power subsystem may, because that's why I put 0 to 1 there in some configurations, may have like a sensor directly on the brake pedal to kind of see when it's activated, and then basically change the power configuration, right? Again, it's a made up example. So it has direct connectivity to the brake pedal. And if it does have that connectivity, of course, there's only one brake pedal, right? Again, we're assuming commercial vehicles here. So there's one on each side. And then
would you be able to show how to create the arrow again for the block association line? One that I've created doesn't have the arrow, and I missed it when you went through that part.
Oh yeah, okay, I see what you're saying. Well, yeah, so but you do have the diamonds, right? So it created it as a diamond.
Yep, I've got that.
Yes, yep. So like here, for example, same thing, right? I haven't bothered to turn the arrow. So again, it's because the tool forces us, right, to create it from here to here, which means that they do put the arrow there, but it's literally hidden right behind the diamond. Plus, it's the wrong direction, because we want it to go right from the hole to the part. So what you need to do then, you could do it 2 ways. You can just go to the properties. So you select the connector, and then you have a property window, right? You switch it around, say destination to source. Or if you don't want to use the property window, you can just right click, and you're going to see, where is that? Under advanced, yeah. So you go under the advanced submenu, and then there's a change direction, right, from destination to either way. Now, the other thing you can do is just when you build, let's say you have a complex diagram you need to build, and you don't want to sit there like one by one having to fix up your connectors. In this test model, you can copy it to your production model afterwards. I created a little script that will kind of do it for you. So let's do one more. Because I got lazy. It's too much work. And I just you go specialized scripts, and it would be like set part aggregation direction. There's a couple other things in there, but set part aggregation direction, and it will just do it for you. So you can kind of do it at the end, one shot. Yeah. I mean, it's like a 10-line script, right? But it just saves so much time that it's worth doing. Now, at some point where you say, well, here you're showing me the parts 2 ways, right? Remember that, it's showing me here as a compartment. So every time I add something more in here, the tool keeps growing this block too. But it's like you say, well, I don't want that, right? I don't want the tool to keep resizing the block because it keeps adding parts as I build my diagram. Then remember, you have compartments, right? So you can right click. There's a Control-Shift-Y shortcut key. So after a while, you get used to that. We say, okay, don't show me the parts anymore, right? In this case, let's also take off the satisfier, right? Let's just keep it simple. I will take off the notes as well. Actually, the notes come from the diagram. So let's fix that. Right. So let's take off notes because I had notes in here. Yeah. Okay. Right. So now we can kind of, resize this thing. And I mean, again, if you want to show the parts or whatever, right, it's up to you. I mean, it's, you make that decision, but otherwise, right, that graphically it keeps expanding as you build up the diagram. So it gets annoying at some point because it forces you to keep pushing things down, right? So yeah, so you should have enough information now to to build this. And by the way, here, I mean, there's no, I just literally overlaid, it's just graphically like moving the line so that they, there's no magic here, right? I did this manually, just move them so they look like it's one, they also nicely
That's what I
combine
was
into
just
one.
about to ask.
Yeah, yeah. And there is actually a
It'd be
line
nice if
style
they
that will let
snap.
you do that. Yeah, there is a line
Oh,
style, but you have to change the line style to do it.
okay.
They call that a tree style. So like, I'll just show you here, like for
Oh, right,
example, but
right. Okay.
I would have to change the line style to, I think it's tree style vertical. Yeah. And now I have to
Yep.
change, well, yeah, and I don't want to, in this case, I could actually say, right, and then apply line style, all connectors of the same type. And now if I put block here, right, to kind of build a kind of hierarchy, right, so, which is pretty neat. Doesn't always nicely work that way, but yeah, that's, if you want to do that, tree style vertical. So that I could have done it that way, but I can tell here just graphically looking at it, I just manually moved them so they looked okay. And this particular connector here, the one that kind of jumps all over, right, like this, very likely you're going to have to change the line style to orthogonal, like I showed you yesterday, right? Otherwise, you're not going to be able to make the bend, or at least not easily.
I had one other question. Sorry for so many questions.
Yeah, no, that's the whole point of doing a training, right? That's to ask
Yeah.
questions.
So, for example, the power subsystem block to the brake pedal block, on the top, like on the power subsystem side, you have a 0.1, and on the other side, you have a just a simple 1. So I understand that the 0.1 means that the reference that you could have either 1 or 0 associations. But
That is
then,
correct.
like, why is there a 1 on the other side? It's the part that I don't get.
Well, so it's the multiplicity on that side of the relationship, right? So here, basically what I'm trying to convey, right, is that there's only one brake pedal. So in terms of like for the tool to create parts, right, it's just there's a single brake pedal part. So that's important here to put the 1 there. Here, by doing zeros, this conceptually what this means is it's optional. Right. So in other words, that relationship, if it if it exists at all, if this is 0, obviously there's no there's no real instance of it. So it may or may not be there, and that would be configuration dependent. Maybe on some particular configuration of the vehicle, right? Whether it has that sensor directly on the brake pedal or not, whether it needs it or not. Maybe if it's an EV, right, it needs it, or maybe it's depending on the combustion type that it used, whatever, right? So it's basically saying, okay, it may or may not be there, this relationship. That's what the 0 to 1 means on the power subsystem. In other words, the power subsystem may or may not require it, right? So that's where it could be 0 on that side. But if it does exist, it can only be 1 logically, right? Because there's only one brake pedal. Does that make sense?
Okay. Okay. Yeah, I think I got it.
So generally, you don't need to put something on that side. I mean, it's like not really important. Well, and if it's bidirectional, we already know that you have to like create 2 connectors. So it's not that big of a deal. But but sometimes, right, that the also labeling the other side, right, can be important. Most of the time, it's not.
Okay. Okay. Thank you.
So on a line for that goes from power subsystem to the brake pedal, you've got two labelings of the multiplicity.
Mm-hmm.
How did you do that?
Yeah, well, so on the connector side, right, where's the, so like here, for example, right? So, well, actually, let's take a look at this example here, right? So that you have the connect, you have the source side, right? So we know the source is block 1, right? So if I wanted to put multiplicity here, like in the example, right, it's a 1. But then if I also wanted to put multiplicity on that side, right, like the 0 to 1, you switch, right? You go to the target tab, and the tool will tell you, right? Now you're on the side of block 2, and here I would say, like, if I follow the same example as the exercise, right? So now I would get 0 to 1 on that side, and you can leave, so you can actually move these little labels, but it would be more ambiguous. I think it's better to leave it here, right, to show, okay, so it's 0 to 1 on this side. So you just go, right, source to target. If you want to put the number, right, because this source will control this side in this particular example, right? And then the target, of course, right, because we created it that way, will control either a label or multiplicity on the other side. Now here, when we create, when we're not using the black diamond, right? We just use a regular reference association. You are kind of building a traditional way, right? You created it from A to B, so the tool's going to look and say, source, right, is block 32, which is correct, right? Target is block 33. So if I wanted to then set the multiplicity here, generally, right, because it's unidirectional, since I created two relationships, then I would put, so here maybe it's, one too many, right? Maybe I can have, any number of these block 33s, but on this side, it's always going to be, the target is always going to be 1, for example, right? So block 33, every instance of block 33 will have a reference back to a single instance of block 32, but block 32 has at least one, but could be any number of instances of block 33, right? When the hardware world, this happens very rarely, but in the software world, it's all the time. But you have any number of, customers, right? Any number of something.
Okay,
Yep.
thank you.
Yep.
Hey Frank, one question. Could be stupid. Is there undo button?
Well, depends on undo for what, right? So, like, for example, if you just do graphical changes, right? We did that
Yes.
yesterday as well, right? So if I, come on, Alt tab. If I just see, like, when I move this, right, I can do undo. But if you say, oh, I just created a connector and it's the wrong connector, something like that, well, there's really no undo, because it's like I said yesterday, right? It's an immediate update to the database. So that what are you trying to undo?
Well, I try to add basically a connector, but somehow one of the block added the parts, another subsection. So I wanted to, or do I just go and, I mean, I could go to the properties and delete those, but I was just wondering if there was like inherently undo button
Yeah, only for graphical, purely graphical things. There's an right. You just do Control Z like you would in Visio or PowerPoint or something
Yes.
like that, right? But yeah, once you added something into the database, I mean, it's like it's there. If you could fix it up by changing a property, sure, right? But if you need, like in this case, if I wanted to undo, if I say, "Oh, this is a mistake," right, or didn't do the right thing, right, I'm going to just say Control Delete. Remember from yesterday, right? And then in this case, the tool is going to say yes. Now, because the tool automatically remember that as part of, well, as a result of me building that relationship, they created, right, this particular property in here, right, which is a part. Then when they notice that I want to delete the connector, they'll say, well, since you have a part there, right, do you also want to delete the property that corresponds to that particular relationship? And I can't see any reason why you'd ever say no. Why do you say keep? I mean, I'm sure there's some special cases, but like, okay, I want to delete, because when you recreate it the right way, whatever that would be, right, then you'll recreate the part also correctly. So to let the tool do it. Right, so you just say delete, and so now I get a clean, right, and I can start over again. That's probably your best bet, is to if you created it like the wrong way, or the part went in the wrong side or something like that. Yeah, then to just delete the relationship. Make sure you delete the part that came with that, and then just start over. So if you're actually showing the parts, right, it will look like this. But you can also at the end, if you're done, take a look at kind of in the folder structure in the browser, right? And this is kind of the structure as it should be.
So I know that graphically doesn't matter, but just to like do it the correct way. Again on the relationship from power subsystems to brake pedal. You said that usually the correct way to do associations is going from the yeah, I mean from the subsystem to the whole, or from the part to the whole. Um, that's only for part associations, or
Correct. That's only for part. Yeah. So part
oh,
associations, the tool kind of forces it to do, because it's counterintuitive. At least I find it counterintuitive to have to do it that way. But they force us to kind of do it that way, to go from the part right towards the container, if you will. So yeah, in that case. But if you just do like here, right, between power subsystem and brake pedal, I mean that is more like the intuitive way to just say, okay, I'm going from A to B, right, and my arrow is going to go out to B. And it's just that's just how the tool wants to build it. I haven't found a workaround for that, unfortunately. So yeah, so that these part associations with the black diamond, they're a little bit to me they're counterintuitive the way the vendor implemented it. But
okay.
it's kind of let me know when you guys are at a good point, because I can't see your screen, so I don't know. Once you feel comfortable building it, then we can
I'm good from
continue.
my end.
Okay. Anybody wanting a little bit more time? Or having any, struggling with any of these things? So just on a little side note, right, whenever you have a multiplicity greater than 1, right, like the 2 and the 4, you're going to see automatically the tool put something there, say unique, right? It's part of the UML SysML specification. The tool just has to do it to be compliant. But what does it really mean? Well, it's basically to say that by default, you could change that. By default, this is a set and not a bag. In other words, that each wheel hub assembly is unique, right? And in the hardware world, it always is. Even in the software world, right? I haven't seen too many cases of using a bag as opposed to a set mathematically. But that's what it implies, right? There's like 4 distinct wheel hub assemblies, right? And again, kind of makes sense, but it's part of the language, so they have to show that. Yeah, it's okay. So we're good here. The concept of an interface, right? So we looked at the regular block, right? So the ones that kind of you're going to be your main building block. And so actor, I have no idea why they put actor in here, right? I mean, that's like a tool quirk because it doesn't belong here at all. It belongs in the use case toolbox, but not here. So you kind of ignore actor. But the other there's two more kinds of blocks, right? One, the constraint block is what we would use for parametric diagrams, which we're not going to cover in our class this week. But we are going to talk quite a bit about interface blocks. So what's an interface block? What is it for? So if you're familiar with code a little bit, and you understand the concept of an interface, like a Java interface or C++ interface, things like that, it's kind of similar in the sense that it is a declaration, right? So the interface block in itself doesn't do anything like a real block, right? Which could have behavior and properties and things like that. On an interface block, the only thing you're doing is, excuse me, is declaring. You could declare properties, you could declare even function calls, you could declare behaviors, but that block itself, the interface block itself, does not implement anything. All right, so it just like in object-oriented languages, like um, C++, C Sharp, etc. Right? You have the concept of an interface. It defines a contract. That's how I like to look at it, is in terms of interface. To say, okay, here's the contract, and that particular contract is going to govern at some point the connectivity between two real blocks, right? And it's the way that that particular contract gets attached to connectivity between blocks is like we saw briefly before, when we're going to have ports. We're going to have ports. So each, let's say block A has a port, block B has a port, and then we're going to say that these ports are connected, right? There's a connected, so either physical connection, right, or logical connection um, through to the between the two port between the two ports and the two blocks that own the ports. And so therefore what we can do then is associate this interface sometimes on one side, but generally on both sides of that contract, right? So this particular interface will then govern, right, the contract between the two ports. So we're going to see lots of examples once we talk about ports. Here, I just want to give you some background. So there's a direct relationship between interface, block, and ports. That's the only place that you use interface on, unlike like UML models, right? You have interfaces on a class and things like that. Here, it's basically just connected to the ports, and it will specify what is allowed to happen, right? So it constrains or governs what kind of connectivity is allowed, right, between two components of the system through that particular port. And ports can contain ports, right? That's fine as well. But let's see, do we have next slides? Oh yeah, there's a couple of examples here. All right, so so this particular set of examples of using interfaces, right, of defining the interfaces, is basically connected to or is part of a alarm system domain, like uh, what's one of the big alarm companies, ADT, right? I think something like that. So it, so that how it controls, right, the all the different interface, all the different sensors, right, that are involved in, let's say, constantly monitoring a particular facility, whether it's a commercial property or just your home, etc. Right. So you're going to be lots of interfaces because you have lots of sensors, lots of things that can happen. And so there's going to be a number of these interfaces specified, right, between all the different components of the alarm system. And some of those, right, so you can put properties. This is one example, right, of using interfaces, but like here, you actually see it's a function call, right? So the block that implements, that realizes this interface, right, would have a function, needs to have a function called notify speed change, that the other block, right, that's going to use this same interface is allowed to call, right? So this is but here you're seeing it in terms of properties, and the interesting concept of flow property, which we'll talk about a little bit later today or tomorrow, is that you could put a direction on it, right? So it's like it's a property, but it also implies that it's going to flow, right, across whatever that connection is, right? And again, it doesn't. The property itself could be like a physical thing, right? It could be like power or electricity, right? It could just be bits and bytes, right? It doesn't matter, but there's a direction to it. And so, for example, in this interface, this would be an interface where you have bidirectional flow, because you have one direction is going to provide the site status, the status of that particular alarm system, and then the other direction is going to come the occupant, right? Like you basically entering your building and hitting on the control panel, right? And you type in your code, so you either arm the system or disarm the system, or you request it to do something, right? Run a test, or so that would be occupant input, right? You see one direction, right? It's the status going in one direction, and the end user of that alarm system basically requesting it to do something, right? So in some things like just one directional, most of them are one directional, but some of them also, like the investigative request, investigative data. So it can be, right, interfaces that are used in both directions. That's another example of using interfaces in terms of having particular flows on them. And you'll see some other examples later on, right, that use interfaces. But that just give you some background. What is an interface block? Now, So we've covered the two kinds of blocks, what we're going to see in the class this week. Now on the internal block diagram, right? So essentially what you do when you want to create, model an internal block diagram, if we go back to my little example here. So I have my block 2, right, which has these three parts. And if I actually look in the tool, I hid the compartment, right? But we can see that that my three relationships, right, resulted in the three parts being part of block 2. So now I can basically say, okay, let me, basically start understanding, right, how the internals of block 2 actually work. So how these parts are going to communicate and work with each other to accomplish something, right? So how would I do that? Again, you're gonna write. Have you do it in an exercise. You're gonna update the diagram you just built. Um, I'll just show you the mechanics in the tool. You're gonna right click on the block. You're gonna say new child diagram, right? And you're gonna say internal block because it has to be a child, right? So the internal by definition, right? Because you're looking at the internals of that block. So therefore, when you create the internal block diagram, right, you're putting it as a child, right, of that element. In this case, of block 2. And then you just keep it block 2 if you want. If you some systems are fairly complex, you can easily have 3 or 4 internal block diagrams for a given block that is very like a very complex behavior, for example, or complex functionality, and then just label your diagram differently, right? So like we saw in some other examples, there are like environmental context or things like that, right? So you kind of describe the context, but otherwise, you can just leave it like that, just whatever the name of the block is, and that's fine. So once we do that, right, you're going to see the tool, right? It automatically create. Here's so this little icon will tell you there's an IBD under this block. And as a matter of fact, when we see that little squiggly, this is a tool thing. It has nothing to do with SysML, but it's the way for the tool to let you know that, hey, there is actually, right, a diagram underneath the, like, if you will, as a child, right? If you had multiple IBDs, by the way, the tool will use one as its go-to point. In other words, if I double click right now, it's going to go right to this diagram. But if I had 3 or 4, it just picks the first one, right? Because it can't jump into more than one at a time. Yeah, let's see, there's anything else? No. So um, so that the tool takes care of that, right, automatically. So you get a drill down point in here, and then when you double click, right, you're going to go and open up that diagram. So now, in essence, you could manually drag in these 3 parts like into the diagram and start, right, connecting them, labeling them. But the tool has a pretty neat feature which is called synchronization. So whenever you make changes to the BDD, you can just go back to your IBD and say synchronize, and then the tool is smart enough to see, oh, I have some new parts, right? They'll add them into. If you deleted a part, obviously it's already gone. So so you say synchronize, right, and then they bring in, right, here's my B3 1 to 4, my block 3, right. So these are now the parts, the internal parts, right, that particular block 2 is going to use, right? And again, you'll see that the tool puts the little labels there, right? My B3 1 to 4. If you go back, right, my B3 I'm sorry, B32, all right, but B3 label, right, 1 to 4. Here I didn't put multiplicity, so it's like 1, right? The other ones are going to be 1. Here it's going to be 1 explicitly stated, right? And then let's say, right, here's also block 33 is a 1 implicitly because I didn't actually specify it. And for the sake of the exercise, again, we're going to focus just on the tool mechanics, right? Later on, I'll give you some realistic IBDs to build. But for now, I mean, it's like, okay, if I want to show that, because these, well, here I actually see that there's a block 32 to block 33, right, connector. So logically, I would expect then whenever I look at the IBD, right, to also see connectivity between these 2 blocks. But the tool does not automatically like say, okay, well, I'll give you a connector automatically, right? So it's up to you to have the connector built, whatever way. It's a little bit in so the meaning in SysML, right, of a connector. So this is the element when you're inside an IBD, right? What you should use is not dependency, not item flow, it's connector. Right, we will talk about item flow. I think I'm covering that later, but it's connector. Binding connector is used in the context of parametrics diagrams. So we're not going to use binding connectors. But here you just use a regular connector. If, if you look at connector in the SysML specification, it says that by default, it's considered bidirectional. Now, what happens in the tool, this is another quirk in Spark's tool, it's no big deal. I wouldn't worry too much about it. But when you look at it, right, and when you see there's no arrowheads, to you, it should mean it's bidirectional. If you look in the tool, it says unspecified, right, which that's not bidirectional. But the reason that the Sparks did not do bidirectional is, because they could have, right, automatically made it bidirectional, is because in UML, bidirectional means show two arrows. And they didn't want to do something special for SysML, because in SysML, you're not supposed to put both arrows, right? So SysML is a little bit different from UML. And so typically Sparks doesn't want to do something very specific for one language or another. But anyway, so it is what it is. But just when you look at it, right, kind of ignore the unspecified. Know that in your mind, right, it means that these two guys talk to each other bidirectionally. Now, if we look in the BDD, that's not true. Here we're saying that it's only going to be from block 32 towards block 33. So if you want to be consistent, then what you need to do here in this case would be to say, because I created it that way, right? To say source to destination, right? No, so now my arrow here, right, corresponds to, again, the tool does not automatically do that, right? But now logically, I'm consistent. To say the connectivity is that way in the BDD, so logically when the parts talk to each other, right, they should follow the same convention. They can actually, in this particular case, I'm not saying you guys need to do that, right, but just for your own information, you can literally, because the connector logically is an instance of either, and I would have to go back here, is an instance of either a pod association or a reference association or shared association, right, any of those three. So if you right click on the connector and the BDD, you can literally go and say under the advanced and say set connector type. And then the tool will look and say, okay, what is there a relationship between these two blocks, right? And at the BDD level, and say, yeah, okay, I found one, right? There's an actual relationship to say, okay, now, right? So anonymous, why? Because I didn't label this relationship here, right? But let's actually put a label there, just for kicks, right? So just I can have some meaning, so maybe I'm basically saying this is going to be some kind of electrical connectivity between the two, right? So if I look at, right, it's going to say electrical here. Yeah, I mean, it's overkill probably, right, for what you're trying to do. But I'm letting you know the logic behind it, right? So these are instances of blocks. So then logically, when you have connectivity, this kind of connectivity between the blocks, right, then these are the instances of what you've defined as connectivity in the BDD. So that's how the specification looks at it, right? In real life, we would need ports on here, right? We need to show how, well, technically, I mean, do you have to have ports? No, SysML doesn't say that. I mean, this is not invalid SysML. It really depends from your perspective as a team. It's like at what level of abstraction do you guys want to model, right? So you want to be as precise as possible, as close to the real world, bits and bytes and hardware, etc. Or are you just trying to, in your diagrams, try to give a general, right, like a more abstract view of the world to say, yeah, I mean, these two components of our design talk to each other, and you could put a little label there if you want, but we're not going to try to narrow it down to something more precise, right? I mean, and that's your choice, right? Or you could have some diagrams where you take a kind of a higher level view, and some other lower level diagrams where you go into extreme detail, right? You try to be as precise as you possibly can. So depends. But if you want to add a level of precision, then really should thinking about ports, right, which we'll do later in the class. And then let's say, but maybe there's also connectivity from block 1 to block 33, right? So I guess, and again, you'd have to decide, is it really bidirectional? If it's not bidirectional, then indicate. So maybe it's block 33. So that would be like destination, right? That actually talks right to block 1. Which in this case, you would say, well, you're not showing that in your BDD here, right? Because we're not, which is true. Again, the tool, they don't have like a built-in, complaint. It's not like going to start complaining and say, hey, if you model a relationship in your block diagram, in your internal block diagram, but you haven't modeled it, you kind of have, right? You have an inconsistency. Well, okay, that's up to you to resolve, right? But that's the general idea of these, right? So the nice thing is, again, you're going to come in, right, and just say synchronize, and then the tool will automatically do a delta, right? So in other words, if I synchronize again, that should change because I haven't added any new blocks, right? If I did add a block in the BDD, another relationship, right, then they'll bring that in, they'll bring the part in automatically for me. If I did further level decompositions, let's say that, block 32 here, I'm going to start decomposing it, right? And in terms of like another part association here. When you do it, when I synchronize now, again, right, the tool does not drill down, right? So they only look at first. So basically they say, okay, you're decomposing block 2. I'm going to give you level 1 decomposition automatically, right? Now, but if I wanted to show that there's actually a block, let's see, which one did I do this on? Block 32. Block 32 has an internal part, and maybe that internal part, right, plays a role in some of the connectivity, right? Then what you have to do is like manually make this thing bigger, because it's contained right inside block 32. And now this is where you would remember that features window, right, that I mentioned yesterday. And you're going to look at the parts, right? What are the parts of block 32? And it has, in this particular case, which one is it's block 34, right? So I'm going to say, okay, I have block 34. Right? This would basically, right, this is the one I just created, and I want to show the part because maybe the connectivity is not, I mean, it's like inside, right? It's like literally doing this. Right? That does not invalidate my relationship here, right? Because it's basically this is part of. So from that perspective, you can say this is kind of a black box, right? And but the actual connectivity, if you actually look inside, right? Look inside the actual component, you'll see that physically it doesn't just stop at this block 32. It actually literally goes inside, right? And maybe just like a wire or some kind of tube or something that you connect, or some kind of line, like a fuel line or something like that, right? Then it connects directly inside. So that, I mean, it's not wrong, but this secondary level, or third level or fourth level, you're going to have to bring it in manually, right? Because the tool will stop. Otherwise, it could just literally explode, right? I mean, if you have a very deep decomposition, so they don't want to do that. Now, in this case, I'm not going to put it back because my relationship is not, is not the same anymore, right? So I kind of cheated here. I was going to put it back, but it can, right? So that's kind of for the exercise perspective, right? The automatic property. So I showed you that. This is the example where the wheel hub assembly, if you remember on that BDD wheel hub assembly, right, decompose into wheel assembly, the lug bolt joint, and the hub. So if I go last view, right, the hub, lug bolt joint, right? So those three guys automatically the tool will bring in. And then here's how, if you need to add subparts, right, here's a slide to remember, so you remember how to do that from the features window on the parts, and then the tool will show you, okay, these are right, things that you can show. And
I actually wanted to ask about that because I think I missed that the first time. Where do I open that features window from?
so that's going to be, if you go to the start ribbon, and you're going to look under the fourth icon is going to say properties.
Yep.
And then in the second column, you're going to top level, it's going to say features, which includes all of this. So it actually doesn't matter which one you click, it will always open up because it's all one window. So I already have it open, right? So you're going to see features, and it will have these right? And then it has different tabs for different purposes. And all of them, well, attributes rarely gets used in SysML, but all the other ones, we're going to use for when we deal with blocks.
Okay.
Yeah, let's see. I think there's anything else. No, block 32, block 32, block 33. All right, so just something. I don't want to. I don't even know what I should mention it because it could actually deviate us quite a bit. But something kind of keep in mind as how the tool interprets what we're doing here, right? If you look at this particular decomposition, right? So, like for example, okay, I have block 32, right, and it has a relationship with block 33, right? So the tool then says, well, a relationship means you have a part, right? So let's assume that there is a part, right, block 33, an instance of block 33, right, that is actually used by block 32. On the other hand, block 2 itself, right, has an instance of block 33, right? So now two things can be true here, right? And there's no way for the tool to figure this out, right? It's not an AI tool. I mean, I don't, only a human being can look at it and say, well, this makes sense or not, right? So let's assume that this is, okay, so let's call this something more realistic. Say this is the actual power supply, right, of the system. So, or at least power supply in this context, right? Because you have potentially in a vehicle is going to have more than one power supply. So technically then, if you look at block 2, right, block 2 is going to have, right, a power supply. And then if I look at block 32, it's going to have, did it refresh itself? No, not yet. So let's see if we can, it hasn't done that yet. So let me, I'm sure there's a kind of a faster way to refresh its mind, but no, let's see, block 32. All right, now it says power supply, right? So I wanted to make sure that it was showing the right thing. So we have block 2, power supply. So, okay, so now the question is, what is true in the real world? Right. So in other words, is it that this block, let's say this is part of the vehicle, right? Some part of the vehicle has a particular power supply, and clearly we only have one block called power supply. That means that technically speaking, it's like it comes from the same vendor, right? It's the exact same part number, different serial number, but it is the literally same part number. So otherwise we would need more than one block where because you have multiple kinds of power supply. But in this example, let's assume one power supply, right, from one vendor, one part number. Okay, but like I said, a vehicle can have multiple power supplies. So the way the tool will always interpret the BDD you build is to say, okay, there's one power supply, right, associated with this block, and there's a second power supply associated with this block, which could literally be true, right? I mean, there's nothing wrong about it per se, except sometimes you look in the real world, you say, well, that's not true, because it really it is the exact same power supply, right? So, I mean, this is kind of a made up example because technically speaking, if I have the power supply going into block 2 and it owns these parts, then it would just literally, right, have some connect, and it has connectivity obviously to its own parts. It would just pass on the power supply. There'd be no reason, right, for this internal part of block 2 to have its own power supply. But there will be cases where, I mean, where you come up with real life examples to say, wait a minute, this is really the same power supply. But the tool doesn't know that. How would it know that, right? So it creates two parts. So like if in the IBD, for example, right, I have my block 32, and I don't know if you noticed that when I went to parts, right, but it says here's power supply, right, and here's power supply. So it basically assumes that in this context, I'm dealing with two, right, because I have two parts. So that means it is the same power supply. So sometimes, you have to find ways around it. I'm not going to go into that because it would take us too far off track of the training, right? But, you kind of, you basically have to, in the IBD, you kind of reuse the same part is what it boils down to, right? Rather than, so you basically on the decomposition, you don't do another decomposition like I did here, right? You literally are reusing like the power supply from block 2, which in the real world, that's exactly what you would be doing, right? So if you show the connection, you don't use reference association or part association or anything like that, because that kind of it would, because that leads the tool to create another instance, which again you can't blame it for doing because that you don't know, right? The tool has no way to know what is the reality in the world, right? You're dealing with one power supply, that's one and only, or does each one of these guys have their own power supply? There's no way to know that. So just keep that in mind. You might say, well, wait a minute, I already have a power supply. Why is it showing me two power supply parts? Well, because your BDD was built that way and the tool has no other way to interpret that, right? So just a little aside there. All right, so let's see, connector. Yeah, we did that. Yeah, the tool does not automatically add the relationships. It's not smart enough to do that, at least not right now. but so this is kind of like 3-level decomp. That's why I color coded them, right? So the tool brought in these top 3 ones, and then I went right using this feature here, right? And I made this one visible, and then so that and then again for wheel assembly, I brought in the wheel, the tire, and then again I clicked on wheel using again that same interface, and I brought in. So all right, is that wrong? Like doing a full decomposition inside a single diagram? I don't think. I mean, you don't want to overdo an IBD, right? Sometimes you just do a separate IBD for wheel hub assembly or for wheel assembly, right? But in this particular case, we're dealing with hardware connections, right? There's like at some point, right? These from a pure mechanical connectivity perspective, right? Once you're down to like the bolts and the mounting holes and the tire beads, there's nothing more to break down. So rather than creating like multiple IBDs, I think I mentioned that yesterday, you just do one summary IBD for the whole wheel hub assembly, and you are going down, right, multiple levels. But don't overdo that either, right? Because it's perfectly okay to just basically say, okay, if you want to understand the detail of wheel hub assembly, right, then you do a separate diagram, and you could still bring in the lug bolt joint at this point, right? But without necessarily bringing in everything else. So it is kind of a trade-off, right? How deep, and how many IBDs you do, right? And at which point you basically say, okay, I can just do a summary IBD, and then at the lower level, I would no longer do a separate IBD for wheel assembly, for wheel, for tire, right? It's like I'm done. One diagram summarizes it all, and it conveys everything I want to convey. So don't overdo it. So what we're going to do is, and this is just a mechanic, right? I just want you to understand the tool mechanics. This is not we're not doing a real IBD yet. But you're going to go back to your hybrid SUV block, the one you just did, and you're going to basically right click it, right? You're going to create a child diagram, an IBD right underneath it. So once you a tool should automatically open up the diagram for you. Then you're going to right click on the background, do the synchronization. So they will bring in power subsystem, brake subsystem, chassis, right? Because that's what we did. If you actually look at level 1, right, there's only 1, 2, 3, right, level 1 blocks here that we're bringing in. So the tool will automatically do that. And then again, purely from a mechanical perspective, right? And you don't have to bring all 3 of them, and just understand, right, what the mechanics are for you to go down a level and bring down, like maybe you bring in the brake pedal here, or you bring in the wheel hub assembly. Now, good question, which I haven't addressed yet, is why is this a dotted line and why is this a solid line? Okay, so let's look back in the BDD and understand this. When you have a solid line, that means that the relationship, the part, right, was a result of a ownership relationship. That means that when I look at hybrid SUV, these 3 parts here, right, are owned by it, right? So that's, versus here, basically you're saying that the power subsystem connects to or uses that part, right, brake pedal, but it does not own it. It's not part of its own domain, right? Its own sphere. It's actually part of the brake subsystem. So whenever you have this reference association, so something without the diamond essentially on it, then just as a reminder of that, right, the fact that that it is not owned by the particular block that you're looking at, then the tool will, and this is part of the SysML spec, right? It will just show you a dotted line. It's like, yeah, you have access, to the brake pedal, but you don't own that part, right? Other than that, that's all it means. It's just a graphical reminder that there's no own. Everything else is seen is owned by, right? So the brake pedal is owned by the brake subsystem. The chassis owns the wheel hub assembly, but the power subsystem does not own the brake pedal. That's all that means. Right? So you can connect it any way, the way you would do to show connections, any other way. And here I just used connector, right? So the connector, and I just quickly connected these 3 guys together. But in real life, right, we would need to do 2 ports and things like that, which we'll do later. We'll make it more complex. So yeah, just do that. Should take you a minute or 2. But again, this is just focused on the mechanics of the tool, so you feel comfortable with those. Oh, how to do like decompose it? Right. Okay. So like, for example, here in this IBD, right? Let me, I'll take those, I'll take them back out. I don't know why it shows compartments here. So let's get rid of that as well. For instance, properties. So we'll start clean. Okay. So let's say I want to bring in like the child parts, right, of this particular guy. You're going to go to the open the features window. We just talked about that, right? It's under property features. You can just click on any of these. And then I like to dock it here, but that's your personal choice. And then, so in this specific case, right, I mean, when you click on the parts properties of that part, right, so like parts that have parts, right, your tool will tell you, okay, so you have like the power supply, you have block 34. Let's just say I'm only interested in this, bringing out block 34. Maybe that's the only one relevant for my diagram, right? And then the tool will bring them out like that. And if you change your mind, you just undo the check mark and it will graphically remove it. So it's like, on or off.
So
But,
what do you do when no parts come up in the parts and properties thing? I mean, it's just a
Same
step.
question.
well, if you look at from the exercise perspective, let's go back at it. Let's go back to the previous exercise. If we do a sanity check, and you could, make your screen visible to me but do you kind of see like power sub, like for example, hybrid SUV has, right, if you look at the app, it should have 3 parts, right, like power subsystem as a result of you doing that. So if those are not there, then yeah, nothing's going to show. Or if on the power subsystem, for example, you're not seeing, remember these 2 connectors here, right? Power subsystem related to wheel hub assembly. And so if you don't see under power subsystem those 2 guys, then the tool wouldn't show you anything. If they're there in the browser, but they're not shown in the features window, then there's this interesting problem. Because then we will have to look at it at the tool, why the tool isn't doing the
So
right thing.
here, I can share my screen real quick.
Mm-hmm.
Share this one. So
Yep,
if I click
I can
on
see it.
hybrid SUV, I've got the 3 parts associated down here, but
Great.
then power subsystem, I've got nothing.
Um,
And
let's
then when I
actually look.
click into the internal and I click on one of
Yeah,
these, it shows
obviously,
nothing.
yeah. If there's nothing, if there's no parts, so scroll down a little bit in your browser. So let's take a look at power subsystem. Just want to double check. Okay, yeah, it has nothing in there. Okay, let's try. So go back to the BDD for a second, and then do a. Well, first of all, do a save all. So right click at a tab and yeah, and then now also do a reload. So you can right click the tab again. This one, the BDD, yeah, right, and say reload. Let's see if that, did that cause any refresh? No, it didn't. So the interesting part is why did it not? Um, So it basically has an issue with your reference connectors, right? So let's redo one of them, right? So let's just take, for example, the power subsystem to the brake pedal. That connector, yeah, just do a control delete on it, and we'll just recreate it from scratch. Actually, that was not a control delete. So do control Z, it's still there, right? Make sure when you yeah, do control delete. So the tool has to prompt you, right? So I want to make sure that it's completely
That's
done.
right. Yep.
Yep. Okay. All right. So now take reference association. Is that how you do it? You did it from the toolbox, or did you use their quick link?
Oh, I did it using connector, not
Connector. Yeah.
references.
No.
Yeah.
See,
Okay.
connector, logically, connector should not be there because connector only applies to a IBD. So that's another tool issue because they should never have put connector there. It's very misleading. Okay. So
Save
now, well,
that
let's yeah, save that.
and then
Let's double
refresh.
check on the let's double check in your browser that power, because okay, now I do see something under power subsystem. See, there's a little greater than sign. Okay, right. And you're probably going to have to redo wheel hub assembly as well, right?
Yep.
Because I don't know that you can change it up. Well, even if you fix it on the fly, you know, it probably, the tool's not gonna be smart enough to redo it. Yeah. And you can remember, you can do that from the property window, right? You don't need to bring up a dialog box. Yeah.
Yeah, that's right. Well, why can't I grab this?
Yeah, and so now change the line style to make it orthogonal. That's kind of the cleanest way. Again, you could do that from the from the window. I know it's kind of these bad
It's just
habits people
habit.
have. A habit to
Yeah, it's
say,
habit to
bring
double
up
click.
control. Yeah, double click. Yeah. Okay. And then I
So
think, yeah, I had a
save
2
that.
on the multiplicity. That just doesn't matter. At this point, yeah, so save, and then I can actually see it in the browser. I see that it did the right thing now. You have them.
So I reload
And so
that.
now click on features. Yeah, go to the parts, and you should see your 2 parts there.
But they're still not showing up. Oh, maybe because these are also connectors, not part. Oh.
No, that's fine. I mean, there's supposed to be connectors here. The question is, why is your B2 power subsystem?
So on the IBD, they should show the parts regardless of if we put any kind of connectors, because they are supposed to be inherited from the
Exactly.
BDD.
Yeah. It's not
Okay.
inheritance technically, but yeah, I understand what you're saying. Yes. Yeah, the BDD basically has these parts, so therefore, click on power again, and then go to parts. You may, let's see, maybe we need to refresh, or click on in that feature window. See at the bottom where it says show owned inherited. So like sometimes okay.
Ah,
Yeah.
there it is.
Yeah.
Okay. Gotcha.
Yep.
Thank you.
And so now you can just check mark, and then, yep. So yeah, anybody else having the same issue, double check that you really should look at the browser and the BDD side, right? And make sure that the parts are there. Because obviously if the parts are not there, then, the IBD cannot show them, right? And so maybe you created maybe you used the wrong connector, like Rich did, or maybe there's some other issue.
So when I added the check mark, it created 2 new lines in here as opposed to just adding a check to
Well, so
the one
the
that I
check
clicked on.
basically says, yeah, so this is how the tool interprets that. Again, and it's not technically wrong, is basically say, okay, so you're pointing at the BDD level, right? You're pointing to these, like for example, brake pedal or wheel hub assembly, and then the IBD saying, okay, I'm going to connect these things, right? Because that's why you would bring them in. So when you connect these things, the connector should not go into the definition, right? The one that's part of the BDD. It needs to go into, like, so in other words, the B3 power subsystem, right? Now the part that you basically expanded, right, needs to contain these 2 subparts. And if you actually look in the project browser on the right there, and you just click on the little greater than sign next to B3, right, you'll see, no, yeah, that one, right? And because now it's basically showing, okay, I have the brake pedal, I have the wheel hub assembly as part of B3, right? So the instances within instances. And technically,
Okay.
that's how the tool has to do it. So, and that's why you suddenly see, okay, well, how come there's 4 of them? Well, 2 came from the definition, the ones you check mark. But if you look at the ownership, you'll see the difference. See, what the tool does is it creates 2 more parts.
Oh, okay.
But then it'll say, okay,
So it's
this
saying that
came right.
these live elsewhere, but they
These
are
live
linked to
elsewhere.
it.
Right,
Okay.
they're linked. Exactly. That's exactly what they're doing. Yep.
Okay. Gotcha. Thank you.
Yep. All right. So let's see if I can grab control again. Yep. Share. That's why it's good. It's good to do these kind of manual exercises, because otherwise, I mean, it's hard sometimes, right, to figure out exactly what's going on.
Yeah, absolutely. Because it's those nuanced little problems and little details that it's hard to
Gotcha. Yeah.
to work through when you're just reading the PowerPoint.
Oh yeah, yeah. All right, so let's do that. Last viewed destination. Oh, okay. Well, just skip through it again. So anybody else needing help in terms of like getting this to pop up? All right, so let's continue a little bit now with signals.
Oh, sorry,
Yeah.
I did have a question. It's
Sure.
a small part of the functionality I don't understand. So, may I share my screen just because it's going to be a bit easier to explain
Yeah, yeah, absolutely.
my question? Okay,
Mhm.
great. You're here. Oh, share screen. Okay. Share screen. Sorry, I'm new to GoTo.
Yeah, they just updated the
Oh.
interface, so it's
Oh.
a little bit more complicated than it used to be. Yeah, okay.
So here, when I select both, I do get both blocks, but then like to make it like your diagram, I should be removing one of them. But when I do, like I get the
Yeah,
references section.
exactly. I had the same issue when I just did it in my little example. So
Okay.
that just the tool automatically, does it, configures it. So what I did in this case, you could just right click on the power subsystem there, and
Okay. Sorry. On the
yeah, the
power
one more,
source. Okay.
yeah, and then we see where it says compartment visibility. So it's like the sixth or seventh one down. Yeah.
Okay.
And then at the bottom, see where it says references. Say, okay, don't do that.
Yeah.
I don't know why they
Okay.
automatically do it. It's kind of silly, but yeah. And after
Okay.
that,
And
even if you check mark it again now, and then you remove it, it shouldn't do it again. So try it. So now, yeah,
okay.
and now,
Yeah, that's great.
yeah. But it's like for whatever reason, they think that you want to see it in a compartment when you really don't.
Okay.
Yep. Yep.
And very, very quickly on this one, on the quite the opposite. I couldn't get it to show the references. So would it be the same thing? Just probably yeah. Okay,
Yep.
okay, I can fix that on my own time. So okay, that was it. Thank you.
Yeah. Exactly. So if you turn it off, right, depending on the need.
Mhm.
And then just be aware that sometimes you expand it that way, and now you have to fix up your whole diagram, right? Because
Oh
the
yeah,
tool needs a lot more screen real estate. Yeah.
yeah. But okay, I can do that. No problem. Thank you.
Okay. Yep.
Now, how do I stop sharing?
I think I can take control from here. Let's see.
Okay,
Hold on. Yeah, it worked.
great.
All right, so let's take a look at signals. Signals, by the way, SysML, right, are exactly as they're used in UML. So it's like absolutely no difference. So a signal is a specification, right, that's going to identify the content, or at least basically you're using it uh, when it boils down to it, right? What it boils down to is that you're using it to describe asynchronous communications, right? So, and the perfect example of that is, of course, is a sensor, right? So a sensor, could go off when it's something triggers it. Some sensors go off, like say 100 every 100 milliseconds, right? They automatically like sample. Maybe they sample the environment, the air quality, or they sample your road condition or something like that, or the outside temperature, right? So it depends. But in any case, when a sensor, generally speaking, right, when a sensor does not really individually sends information to a very specific target. Right? It's like a broadcast if you think about it, right? So that sensor is going to go off. It's going to build. It's going to provide some information. It could just be that the sensor goes off, and the mere fact that it went off is the notification. In real life, a lot of times, the sensors carry information, right? Like I said, temperature, current outside temperature is a good example. And so it's going to basically make that available to any part of the vehicle in this example, right, that would be interested in that. So it's not like a direct synchronous, connection, right, between two parts. There's other kinds of, even the software, there's cases where we do like, asynchronous communications, where you just basically, you publish something, if you will, like in a publish subscribe pattern, And then if anybody's interested, they'll pick that up, and if nobody's interested, you don't care, right? You just continue sending your notifications, your messages, in an asynchronous way. But the idea of a signal is basically that then the question is, what's the payload of that signal, and what's the content, right? What are the properties that are part of that signal? And so you have to have an element, right, to do that, which you could just do it with a block, but signal has special meaning. You'll see that also in activity diagrams, where you really want to isolate. We want to be able to flag that something is a signal, because the mechanics, right, or how signals get published and subscribed to is a little bit different from just like a regular, let's say, software call, right, with some message going across the wire. So, right, the sender of a signal does not block, right, continues execution, right? And then what we'll do is, so if in your system, if you have sensors or you have any kind of publish, subscribe logic, right, that is involved in it, then the blocks, now the block that is interested in that signal basically, right, needs to say, oh, hey, if that signal happens, I'm interested, right? I'm basically, it has to declare that. And it's going to declare that. We'll see that a little bit later, probably after our break, where you do that by having a reception on it, right? So going back to, if we look at it, let's go back to the BDD here, right? So it's going to be, see the receptions here, right? So I'll show you some examples of how to set that up, and how to model it in the tool. So here's like two examples out of the specification, right, where the signal does really not, it's just a notify and activate. So in other words, the mere fact that the signal happened, it could just be like an electrical, right, on-off type connection that just basically say, right, I'm letting you know I'm still alive, for example, right, and that you don't need to know anything more than that, right? But if a lot of signals will have something more. So this is actually, I took a screenshot because again, it's not proprietary. I mean, it's not confidential or super critical information. This is just things like, from that military vehicle that we were starting to model, right? And we put they have a whole library of it, like literally hundreds and hundreds of signals. And so I just took, I took a few kind of from a screenshot, right, to kind of show. But these are real life examples, right? They're using C++ directly. So when they build the signals, they target a specific language because they generate code out of these things, or they generate something out of it. I don't know, but they wanted it. So you see things like unsigned short int, right? That would match to. These are all like C++ specific data types. But again, this is just what they want to do in their world, right? But you see some real life, like transmission signals, right? Current gear, current range, right? Crank allowed, engine fluids, right? So obviously these come from many different sensors, right? So, a signal that does not necessarily have to have a one-to-one relationship with sensor, with the actual sensor, because in real life, what you do is you group a bunch of sensor readings and then you publish that, like, again, maybe every, I don't know, right, 100 milliseconds or every second, or what as the case may be. Right, fuel status probably not that often, alternator info probably not that info, brake sensors probably very, very fast, right? All the time is like pushing it out all the time at a very high rate. So so these are just like real life examples, right? Of specifying signals. And just to show you, we'll get to that a little bit later when I show you on the behavioral side, right? But so I'll show you at that time. We'll kind of build a quick signal, and then I'll show you how a block can say, "Oh, I'm interested in transmission signals," right? And other blocks will say, "Oh, I'm interested in the fuel status," right? And of course, so a given signal may wind up in 4 or 5 different blocks. Right? So that's that's a common. If you guys model signals, but there's never no block in your design is interested in them, that would be, well, then the question is why have the signal there to begin with if nobody's interested in it, or more likely, right, you forgot to to declare one of these receptions. So on the value types, right, we know that there's, well, okay, so let's take a step back here. Let's take a look at, let's just say that I'm going to add a property. We'll take a much deeper look at properties after the break, after lunch. But so I'm going to just throw a property on here for a second, right? And then whatever that means, maybe this is, I don't know, current, represents fuel level, something like that, right? I'm just making something up. So you define the property, right? You give it a name. And then when you go to the property window, you're going to see there's a tab, right, specifically for things that relate to properties. And of course, the main ones, once in a while, you may have to set one of these things, but for the most part, you're just going to define the type. So what is the unit of measure of fuel level, for example, right? And you're going to define an initial, potentially, you could give an initial value. So say by default, it's 0, by default, it's this or that. So when you look in the tool, right, you're going to get this drop down here. Personally, I mean, I almost wish that the tool didn't do that. The values they're showing you, the choices that are actually correct, but these are the exact list that the SysML specification gives in terms of like out of the box data types, right? They don't say that these are the only ones you can use. Of course, you need to add your own, right? But these are just out of the box, the ones that have to be supported, if nothing else. So, the tool gives us those, but these are just strings, right? So they don't point to anything real in the database because they're not really elements. And what happens is, it's not that it's wrong per se, right? But you know that this set here is going to be, very incomplete, right? You're going to want to have to build your own, right? Like we talked about a little bit yesterday, you're going to want to have your own library, right, of data types that are much more complete, right, than things like than what the list is given here. So the issue then is, I mean, it's not an issue, but it bothers me personally. Maybe you guys say we don't care, but that's fine. Like for example, here I say integer, right? Okay, so I have fuel level, and which is going to be an integer. But on the other hand, I could look in my library, right? And I could say, well, I have my primitive value types, right? So I could have used like, integer here. And of course, this is just a starting point, right? Like we talked about yesterday, you guys could do like long and short and unsigned short and right, but whatever primitives you would type in here. So it's like, okay, if I change this, right? Or in some cases, let's actually add one in here. Okay, so let's actually say that I'm going to have, I'll keep it simple, right? I'll just add a value type in here that's that maybe I'll just say that's an unsigned integer, or in 16, right? Something like that. It's still an integer, so I could literally consider that a specialization of integer. I mean, not that really makes a big difference, but just logically, right? I can say, okay, this is just, so now I have unsigned in 16. I added that into my library. So if I go back to my BDD here, right? So, oh, where's it? No, where did that go? Oh, I see what happened. I've got back to my BDD, right? And now, see, now I mean, it's like, that's not here, right? It's part of my library. You would say, okay, so do select type, right? I can do select type. And then now the tool, right, comes up and says, okay, here's your library, primitive values, right, in 16. So what happens is, so sometimes if you're happy with just like, integer or something like that, you use the tools, drop down, but then you only have as a string. I mean, it's not, versus in other times where that, that list here is definitely going to be very insufficient for what you want to do, then you're not going to use what they have, right? You're going to point to your own. It's the mix of the two that it bothers me. See what I'm saying? So it's up to you guys to decide, right? If that's really, if it's important or not. But generally, when I always make sure to have my primitive set in the library, I never use theirs, never. I have my own Boolean, I have my own integer, I have my own long, I have my own float, whatever I want to, I need to use, right? Then the other reason why I think it's important is that these are just primitives, right? Well, what about like things like I want to show like fuel level, maybe that's measured degree distance, and I have to see if I have anything here that would make sense. What pressure radian, right? Probably not, but but I could have something else, right? A property that's like temperature. That meant sense, and then I could say, well, okay, I have degree centigrade, right? For example, I don't have degree Fahrenheit in here, right? So you're going to have a next level of value types, which is basically not just a primitive now, right? It's not just a number, but it's a number with a meaning, right? So it's like a number that represents distance or temperature or pressure, right, or horsepower, or mass, or volume, things like that. So you're going to use value types a lot because you have no choice, right? You're going to have to create your own library of things like that. And so, then, so at some point, if you do your own primitives, plus you have your own like domain specific, like in your world, automotive domain specific value types you're going to define. And then in addition to that, you also sometimes use the tools like built-in, these are just strings, right? That we don't, there's no representation of those things in the database. You wind up with 3 different kinds, right? Of, if you will, well, 2 of them are value types, but you wind up mixing and matching. That's my only concern. And here, because if you ever needed to change something, you say, well, what are all the places? What are all the properties that we've created that have int16? Because actually we want to go to int32, right? We're going to use a different kind of controller, and these need to turn into 32-bit instead of 16-bit. Well, if you use your own, it's extremely simple, right, to find out. The tool can answer that question right away. It'll tell you exactly all the places that you've used this, because it's an element in the database. If you just had to find out which, all the places you used integer, from their dropdown, not as easy, because it's not a database element, right? I mean, you could find it, but you just not as easily. So that's kind of just my 2 cents there. But I mean, that's essentially what your value types are going to be, right? From a library perspective, that you're going to build those up. And just as, as a what's the right term? As a background, right? So if we actually look in from a SysML perspective, what is a value type, right? Because there is a concept of a data type already in UML. Why they're not reusing that? Well, if we actually draw one in here, where there's a value type, right? You'll see that it has 2 extra properties. There's a quantity kind and a unit. The kind of quantity, I mean, you could specify that, but I think it's really not that critical. The really important thing is unit of measurement, right? So in a sense, you have, from a value type perspective, there's 2 ways you can go. There's no right or wrong answer, but there's probably some decisions that you guys need to make. For example, I can say, okay, if I look at this value type of degree, right, I don't have a unit of measure, because I probably didn't create one in this particular sample model here. But so either by name, right? So I have degree C. Okay, you can kind of assume that's degree, right, centigrade. But what if I say distance, right? A value type, and I just call it distance, right? Just drag that in here as a link. It's like, well, that in and of itself is meaningless, right? I would need to specify the unit of measurement. Okay, so the unit of measurement, right? If you trouble click here, it will actually the tool just look at and say, well, where's your unit of measurement? I don't think I have any in this particular exercise model here, right? But technically what you then do is you create here, you see a unit, right? And you specify unit of measurement. And you can, and so remember that ISO library. So this is where these unit of measurement would come from. And if you actually have like the official symbol and a description, and so that's what the library would load in, is the unit of measurements, these thousands and thousands of unit of measurements. But if you just create your own, right, then you could say, okay, so, that would be like, let's say that we're going to do distance in feet, right? So I can say, okay, feet, or foot actually, but it's okay, right? So it's just in feet. And so now when I go to my distance value type, right, now I can be precise. I can actually specify my unit of measurement here, right? And I'm going to say, where did I put this in my sandbox? Right, so obviously this needs to go into the library as well, right? But I'm just defining it here. Okay, so unit of feet, distance, right? And so now the interesting part is this: if I now create a property, you can take these things, by the way, once you create them, these properties, you can take them off graphically. This is kind of nice, right? The tool automatically then shows you in a compartment, but you can't create them in a compartment. You're going to have to like put a property here. And let's say that, again, this is going to be, I'll call it distance as well. As a property, right? But now from a property definition, I wanted to point to this distance thing here. Okay, so let's do that. Well, from a type perspective, we can go select type. There's actually a shortcut. I'll show you a shortcut key in a second. Let's do that. So if you want to set the type as opposed to going to the property, right, and then actually going to the property tab and going to type, there's actually, if you right click on it on the advanced, there's a set property type. And there's a keyboard shortcut, which they're not showing, which is Control L. Why L? Don't ask, right? That's like Control Lima. So if you do Control key on your keyboard, Control Lima, boom, right? That opens up, the choice right away, so you can bypass a lot of these steps. And so now we're going to go in the, I think I picked this from the automotive. We're going to look for distance, right? Here's distance. Okay, so now, and now we can just, make this non-graph. I have distance. Now you say, well, that's not really nice because, it's, when I look at, I don't see this, right? Let's assume this is not on your diagram and you're looking at distance. So, well, you're still not telling me how you're measuring that particular distance, right? Then what you can do, well, all you need to do really from a tool perspective, I mean, this is how they do it, right? If you say the initial value is 0, right, because it will get updated when you actually run your system. Now you see unit of feet, right? So that's not bad, right? The only thing you need to just remember doing is always put some kind of like default value in there. Then that forces the tool to show you what your unit of measurement is, right? But okay, so this is one approach, and is very SysML compliant approach, right, of how to use value types. The other one, which is, my simplistic solution, is just to say I have a value type, and it's, I call it feet, right? And so now, as opposed to using distance, which then has to have the unit of measurement of feet, right? But so in other words, and I'm using value type, the simple value types, right, as just a unit of measure. So the name by convention, then, right, the name of the value type is the unit of measure. So you don't have to like, do it like this. Because I mean, feet is probably not that relevant for you, but you have things like, the distance. I mean, like, length would probably be better, right? And sometimes you have like metric measurements, right? And then you have non-metric measurements. So, if I change this to, let's say, length or size or something like that, right? And then, so I have length unit in feet, but I also need to measure length in inches, right? Well, what do I do, right? So I need to create another value type here anyway. I'm just doing control drag, right? And then I'll say, okay, here, this is, length, but, length in inches, right? Length inch, right? Or something like that, right? And then this one you'd have to rename to say length, feet, right? Because when you just look at the name, so you're gonna have to do that anyway, right? If you use the standard approach, right, that they have. So it's not like you're saving in terms of what you have to create, because here my unit of measurement would become inch, right? Versus here my unit of measurement. So why not create the value type directly in, right? So no, I mean, I'm not trying to influence you saying you have to do it, one way or the other, but I would make a decision to say, let's keep it, either follow, right, the SysML convention, and the SysML guidance, which is basically that, you define your, no, I'm sorry, where you define, right, with the actual attributes like quantity kind. I don't think that's really important, but the unit of measure, right? So you have kind of some examples here of, this is all these value types are basically a specialization of a real number, right? Because all of them are measured as a number, they're not as a string or a boolean or something like that. So things like horsepower, right? And then you have the units, right, like feet and pound, etc. That, right? So you basically need to do both in this case. Quantity kind, I wouldn't worry about, but unit of measure you need to have, right? To say, okay, this weight is, measured in mass, or the distance, quantity kind, because a lot of times, quantity kind and the name is going to be the same anyway. But here, right, this is measured in feet. But you still need to create, like I said, many distances, many velocities, because you want to measure velocity, right, in kilometers per hour, miles per hour, or many other ways, right? So that's your choice. Does that make sense? Why I'm bringing the way I'm bringing it up, to kind of,
Yeah, I think it was.
Yeah, so just think
That's
about
neat.
it, but as a team, right? Talk about it as a team, and decide, because your primitives are always going to be primitives anyway. You don't need to really give it any unit of measure, because it's implicit. As if you say long, it's long, right? If it's say in 16, it's in 16. But once you go to the your domain specific, right, definitions, then you have to be, right, more precise. And so you could do it. I'm not saying one way is better. This technique is definitely more SysML compliant, right? There's no question about that. But just just doing it the more simple way and just creating, we're not bothering, right, with unit of measurement, make your value type the unit of measurement directly. So just express it like this, right, G-force or miles per hour. And then don't worry about, then you don't have to set units. So, but no right or wrong. It's again something that you guys need to think about. Here's some examples of if you do kind of that way, or like horsepower here, volume, pressure, right? As long as you put a kind of default value, then the tool will show you the unit. So that's not the big deal. It's not like you won't know, right? By looking at your diagram, what the actual unit or measure is, the tool will tell you. And I think we just did that. Yeah, I think we covered that pretty much, right? Update the name, right? Yeah. So let's take our break, right? Lunch break for some of us, almost dinner for others, and resume in about an hour from now. Unless you guys have a question before we break.
No questions from me.
All right.
See you guys back at 1 o'clock.
All right.
Thanks, everyone.